Bueno, pasa.
Trained our whole lives for the galaxy's call. Mission aborted against the fallout wall. Broke out and the skies turned to ash. Nuclear shadows, the future's collapse. Crew of four stared at the terminal's glow. Had to steal the ship, had to hit
The Search for Extraterrestrial Life, Fact or Fiction, written in public is capable of communication. Though many of the variables in the equation are still unknown, it has provided a valuable framework for thinking about the odds of finding extraterrestrial intelligence. Since the early days of Project Ozma, SETI has expanded into a global effort involving numerous observatories, private institutions, and governments around the world. SETI researchers use sophisticated radio telescopes to scan the sky for signals that could originate from intelligent sources, and advances in technology have made it possible to search broader regions of the sky and wider bands of the radio spectrum than ever before. How SETI works: listening to the universe. SETI's primary method of detecting alien civilizations is by searching for narrowband radio signals. Signals concentrated in a small part of the radio spectrum. Unlike natural phenomena such as stars or planets, which emit signals across a wide range of frequencies, narrowband signals are often associated with artificial transmissions, such as those generated by human technology. The logic behind this search is simple. If an advanced civilization wanted to communicate with others across the galaxy, it would likely use radio waves. Radio waves travel at the speed of light and can traverse the vast distances of space without being absorbed by interstellar dust or gas, making them an ideal medium for long-distance communication. Additionally, radio waves are relatively easy to generate and detect, so it's possible that other civilizations, if they exist, might also use this technology. SETI scientists use massive radio telescopes to listen for these signals. The telescopes scan different parts of the sky, targeting regions where stars are known to have exoplanets, particularly those in the habitable zone, where conditions could support life. Computers analyze the data collected by the telescopes, looking for patterns or signals that stand out from the background noise of space. The challenge, however, is that space is filled with a wide variety of natural radio emissions, from pulsars, quasars, and other cosmic phenomena that can easily be mistaken for artificial signals. In recent years, SETI has expanded its search beyond just radio waves. With the development of new technologies, scientists are now exploring other forms of electromagnetic radiation, such as optical signals, visible light, and laser pulses, which could also be used for interstellar communication. The hope is that by broadening the scope of the search, we might increase our chances of finding something. SETI successes and false alarms. While SETI has yet to detect a confirmed signal from an extraterrestrial civilization, there have been several intriguing events over the years that sparked excitement, only to later be explained as natural or human-made phenomena. One of the most famous cases occurred in 1977 when a radio telescope at Ohio State University detected an unusual signal that became known as the WOW signal. The signal, a strong and narrow-band burst of radio waves, lasted for 72 seconds and appeared to come from a region of space where no known human-made transmissions were present. Astronomer Jerry Emin, who discovered the signal, was so astonished by it that he wrote "Wow" in the margin of the data sheet, giving the signal its now legendary name. Despite extensive follow-up observations, the WOW signal has never been detected again, leaving its origin a mystery. Some researchers believe it may have been a signal from an extraterrestrial source, while others argue that it could have been caused by a natural phenomenon or a terrestrial interference that was never identified. Other instances of potential signals have also turned out to be false alarms. In 1997, for example, a SETI team detected a series of signals that, for several days, seemed to originate from deep space. However, it was later revealed that the signals were caused by a malfunctioning microwave oven in the observatory's break room. a humorous but humbling reminder of the challenges SETI researchers face in distinguishing between artificial and natural sources of radio waves. Despite these false alarms, SETI scientists remain optimistic. The universe is vast, and the search for extraterrestrial intelligence is still in its early stages. As technology improves, the hope is that we will one day stumble upon a genuine signal, one that could change our understanding of the universe forever. The challenges of SETI, vast distances and time scales. One of the greatest challenges facing SETI is the immense scale of the universe. The Milky Way galaxy alone contains an estimated 100 to 400 billion stars, many of which could have planets orbiting them. Searching the entire galaxy for signals is like trying to find a needle in an interstellar haystack. Another challenge is the time scale involved in interstellar communication. Radio waves travel at the speed of light, which means that even a signal from the nearest star system, Proxima Centauri, would take over 4 years to reach Earth. If an advanced civilization in a more distant part of the galaxy were to send a signal, it could take tens, hundreds, or even thousands of years to arrive. Additionally, any civilization capable of sending signals would need to be transmitting at the right time for us to detect them. Given the age of the universe, over 13 billion years, it's possible that other civilizations may have risen and fallen long before humans developed the technology to listen. If so, their signals could be reaching us now, long after their civilizations have disappeared. Another consideration is the water hole, a specific range of frequencies between 1420 and 1720 megahertz. This range is relatively free of background noise, and it includes the natural emissions of hydrogen and hydroxyl, which are abundant in space. Some scientists believe that if extraterrestrials were trying to communicate, they might use this frequency range, as it would be a logical choice for interstellar communication. SETI focuses much of its attention on this range, though there is no guarantee that alien civilizations would think the same way. The role of private organizations in the future of SETI. In recent years, the search for extraterrestrial intelligence has received support from private organizations and philanthropists, most notably Russian billionaire Yuri Milner's Breakthrough Listen initiative. Launched in 2015, Breakthrough Listen is the most comprehensive SETI effort to date, with a budget of $100 million. It funds observations at some of the world's largest radio telescopes and uses cutting-edge technology to analyze data for potential signals. This private funding has revitalized the search for extraterrestrial life at a time when government support for SETI has dwindled. In the early 1990s, NASA briefly funded a SETI project, but it was canceled after just a year due to budget cuts and political pressure. Since then, much of SETI's work has relied on private donations and collaborations with universities and research institutions. As technology advances, the future of SETI looks promising. The development of more powerful telescopes, artificial intelligence for analyzing massive amounts of data, and the growing catalog of exoplanets and habitable zones all increase the likelihood that we might one day detect a signal from an intelligent civilization. However, the search is not without its critics. Some argue that the focus on radio signals is too narrow and that intelligent civilizations might communicate in ways we cannot yet imagine. Others question whether we should be actively searching at all, raising concerns about the potential dangers of alerting hostile extraterrestrials to our presence. Despite these concerns, SETI remains a beacon of hope for those who believe that intelligent life exists beyond Earth. Whether we find it tomorrow, in 100 years, or never at all, the search itself reflects humanity's deepest desire to understand our place in the cosmos. Chapter 5: Exoplanets and Habitable Zones. One of the most significant scientific breakthroughs in the search for extraterrestrial life came in the last few decades with the discovery of exoplanets, planets that orbit stars outside our solar system. These distant worlds have ignited excitement among astronomers and astrobiologists, as they offer potential new homes for life. But among the billions of stars in our galaxy, how do we know which exoplanets might be capable of supporting life? In this chapter, we'll explore the discovery of exoplanets, the concept of habitable zones, and the methods scientists use to determine whether these distant worlds could harbor life. The discovery of exoplanets, a new frontier. Until the 1990s, the idea of planets existing outside our solar system was mostly theoretical. While scientists had long suspected that other stars might host planets, the technology to detect them simply didn't exist. That all changed in 1992 when astronomers made the first confirmed discovery of exoplanets orbiting a pulsar, a type of neutron star, called PSR B1257+12. Although these planets were unlikely candidates for hosting life due to the extreme radiation from their star, their discovery marked a pivotal moment in astronomy. Just a few years later, in 1995, a team of Swiss astronomers discovered 51 Pegasi b, the first exoplanet found orbiting a sun-like star. This gas giant, similar to Jupiter, was a hot Jupiter, orbiting much closer to its star than any planet in our solar system orbits the Sun. While it wasn't a likely home for life, 51 Pegasi b opened the floodgates for further exoplanet discoveries. Since then, advances in technology, particularly with space-based telescopes like Kepler and TESS, Transiting Exoplanet Survey Satellite, have allowed astronomers to discover thousands of exoplanets in various star systems across the galaxy. Some of these planets are gas giants like Jupiter and Saturn, while others are rocky, Earth-like worlds which hold the greatest potential for life. The habitable zone, where life might thrive. When searching for life beyond Earth, scientists focus on planets that reside in what is known as the habitable zone. Also referred to as the Goldilocks zone, this is the region around a star where conditions are just right for liquid water to exist on a planet's surface. Water is essential for life as we know it, and planets in the habitable zone are the most likely candidates for supporting life. The concept of the habitable zone varies depending on the type of star a planet orbits. For example, planets orbiting smaller, cooler stars like red dwarfs would have habitable zones much closer to the star, while those orbiting larger, hotter stars would need to be farther away to maintain temperatures suitable for liquid water. Earth, naturally, is the prime example of a planet in the habitable zone. It lies at just the right distance from the Sun, allowing for stable liquid water and a relatively mild climate, key ingredients for the development and sustainability of life. By identifying exoplanets in similar conditions, astronomers hope to find other Earth-like worlds where life could potentially exist. However, the habitable zone is just one factor in determining whether a planet can support life. A planet also needs to have a stable atmosphere, the right chemical composition, and other features that make it hospitable. Additionally, while liquid water is necessary for life as we know it, some scientists believe that other forms of life could thrive in environments without water or in entirely different chemical ecosystems, which expands the possibilities for what we should be looking for. Methods of detecting exoplanets. The discovery of exoplanets has been made possible by a few key techniques, each of which allows astronomers to observe planets indirectly, since directly imaging distant exoplanets is extremely difficult due to their faintness and proximity to their host stars. 1. Transit method. The most successful and widely used method for detecting exoplanets is the transit method, employed by telescopes like Kepler. This technique involves monitoring the light from a star and looking for periodic dimming. If a planet passes in front of the star from our line of sight, it temporarily blocks a small portion of the star's light, causing the star to dip in brightness. By analyzing the timing and extent of these dips, scientists can infer the presence of an exoplanet, estimate its size, and determine its orbital period. This method has been particularly effective for identifying planets in the habitable zones of their stars. 2. Radial velocity Doppler method. Another method for detecting exoplanets is by measuring the radial velocity of a star, which refers to the slight wobble caused by the gravitational pull of an orbiting planet. As the planet tugs on its host star, the star moves toward and away from us, shifting the light it emits. This shift, known as the Doppler effect, can be detected by observing the star's spectrum. By measuring these shifts, scientists can calculate the planet's mass and orbit. This method has been crucial in discovering gas giants and larger exoplanets. 3. Direct imaging. Though challenging, direct imaging of exoplanets is sometimes possible, particularly when looking at young planets that are still glowing with heat or when advanced techniques, such as coronagraphs, are used to block out the star's light. Direct imaging allows scientists to observe the planet itself and study its atmosphere and surface characteristics, though this method is far less common due to technological limitations. 4. Gravitational microlensing. This technique involves observing the bending of light caused by a planet passing in front of a distant background star. The gravity of the planet acts like a lens, magnifying the light from the background star. While rare, this method can reveal planets at great distances from Earth, even in regions of space where other detection methods struggle to reach. These methods, combined with the ever-improving technology of space telescopes and ground-based observatories, continue to expand our catalog of known exoplanets, bringing us closer to finding planets that might support life. Earth-like exoplanets, the search for another Earth. Among the thousands of exoplanets discovered, some have emerged as particularly exciting candidates for habitability. These Earth-like exoplanets, known as super-Earths, are rocky planets with a mass larger than Earth but smaller than gas giants like Neptune. Super-Earths are of great interest to scientists because their size and composition suggest they could have conditions similar to Earth's, making them potential homes for life. One of the most famous discoveries is the TRAPPIST-1 system, located about 39 light-years from Earth. This system contains 7 Earth-sized planets, 3 of which lie within the star's habitable zone. These planets, orbiting a cool red dwarf star, have captured the attention of astronomers due to their potential for liquid water and stable climates. While much more study is needed to determine their exact conditions, the TRAPPIST-1 system is a promising target for future exploration. Another intriguing candidate is Proxima Centauri b, an Earth-sized exoplanet orbiting the star Proxima Centauri, the closest star to the Sun, located just 4.2 light-years away. Proxima b lies within its star's habitable zone and could potentially have liquid water. Its proximity to Earth makes it a prime target for future missions, and if conditions are favorable, it could be one of the best opportunities to discover life outside our solar system. In addition to these, other exoplanets like Kepler-452b and LHS-1140b have also raised hopes of finding habitable worlds. Kepler-452b, sometimes called Earth's cousin, is located in its star's habitable zone, while LHS-1140b is super-Earth orbiting a nearby red dwarf. Challenges in determining habitability. While the discovery of exoplanets in habitable zones is a major step forward, determining whether these planets are truly habitable is a much more complicated task. For life to thrive, a planet must have more than just liquid water. It needs a stable climate, a protective atmosphere, and the right chemical ingredients. One of the biggest challenges is atmospheric composition. A planet's atmosphere plays a critical role in regulating temperature, protecting against harmful radiation, and enabling the chemical reactions necessary for life. For example, Earth's atmosphere, rich in oxygen and nitrogen, is essential for maintaining the conditions needed for life. When searching for exoplanets, scientists look for signs of certain gases, such as oxygen, methane, and carbon dioxide, which could indicate the presence of life or the potential for life-sustaining environments. Another challenge is a planet's magnetic field. Earth's magnetic field protects us from the sun's harmful solar winds, preventing our atmosphere from being stripped away. Without a magnetic field, a planet's atmosphere could be eroded over time, making it difficult for life to survive. Determining whether exoplanets have magnetic fields is a complex and ongoing area of research. Finally, scientists must consider the long-term stability of a planet's environment. A planet may lie within the habitable zone of its star, but if the star itself is unstable, prone to flaring or significant changes in brightness, it could make life on the planet difficult or impossible. What's next? Future missions and the search for life. As our understanding of exoplanets grows, so too does our ability to explore them in greater detail. The launch of new space telescopes, like the James Webb Space Telescope, JWST, promises to revolutionize our study of exoplanet atmospheres. The JWST will be able to analyze the light passing through exoplanet atmospheres to detect the presence of key gases like oxygen and methane, giving scientists an unprecedented glimpse into the potential habitability of distant worlds. Other upcoming missions like LUVOIR, Large Ultraviolet Optical Infrared Surveyor, and HABEX, Habitable Exoplanet Observatory, will further enhance our ability to detect and study Earth-like exoplanets. These missions aim to directly image exoplanets, allowing scientists to study their atmospheres, climates, and potential biosignatures in much greater detail than ever before. While we have yet to find definitive proof of life on any exoplanet, the search is only just beginning. With each new discovery, we move closer to answering one of humanity's most profound questions. Are we alone in the universe, or is life thriving in the distant reaches of space? Chapter 6. Mars, our neighbor and potential host for life. Of all the planets in our solar system, none has captured humanity's imagination quite like Mars. Often called the red planet due to its rusty surface, Mars has long been considered a prime candidate for harboring life. Its proximity to Earth, its historical allure in science fiction, and the tantalizing hints of water beneath its surface have made Mars the focal point of numerous space missions. But is Mars truly capable of hosting life, either now or in the distant past? In this chapter, we'll explore Mars' history, its unique characteristics, and what we've learned from decades of exploration. Mars in myth and science fiction. An early fascination. Mars has fascinated humans for centuries. To ancient civilizations, its reddish hue made it stand out from the other visible planets, and many associated it with war and aggression, naming it after their gods of war, Ares in Greek mythology and Mars in Roman. Its enigmatic nature made it a frequent subject in early astronomy, and its motion across the night sky gave rise to early ideas about its nature. In the late 19th century, astronomer Percival Lowell popularized the idea that Mars could host intelligent life. Using a telescope, Lowell claimed to have seen a network of canals on the Martian surface, which he believed were built by a highly advanced civilization to transport water. Although these observations were later debunked, what Lowell saw was an optical illusion. His theories fueled public imagination, giving rise to an entire genre of science fiction centered around Mars. H.G. Wells' The War of the Worlds, first published in 1898, cemented Mars' place in popular culture. The novel depicted a Martian invasion of Earth, introducing the idea that intelligent beings from Mars might be watching us. Since then, Mars has been the setting for countless books, movies, and TV shows, from Ray Bradbury's The Martian Chronicles to the 2015 film The Martian. But as our technology has improved, Mars has transitioned from the realm of fiction to one of scientific inquiry. Why Mars? The quest for habitability. Mars has long intrigued scientists because, in many ways, it is the planet in our solar system most similar to Earth. Although smaller, Mars has seasons, polar ice caps, and a day that is just a little longer than ours, 24.6 hours. Additionally, it has evidence of ancient riverbeds, lake basins, and minerals that only form in the presence of water, suggesting that it once had a much wetter and possibly warmer climate. Mars' history holds clues that it may have been more Earth-like billions of years ago. Early in its history, Mars likely had a thicker atmosphere and liquid water on its surface, two key ingredients for life as we know it. This has led scientists to speculate that Mars might have supported microbial life in the distant past. However, over time, the planet's atmosphere thinned, and its surface water disappeared, leaving behind a cold, dry desert. Today, the surface of Mars is incredibly inhospitable. The planet's atmosphere is 100 times thinner than Earth's and composed mostly of carbon dioxide, offering little protection from harmful solar radiation. Temperatures on Mars can drop to minus 80 degrees Fahrenheit, minus 62 degrees Celsius, at night, and dust storms can engulf the planet for weeks. Despite these challenges, scientists believe that Mars may still hold some surprises. The water question, ancient rivers and hidden ice. One of the most important questions in the search for life on Mars is whether liquid water, essential for life on Earth, still exists there today. While Mars is too cold for liquid water to exist on the surface for long, evidence suggests that water was once abundant on the planet. Pictures from rovers and orbiters have shown ancient river valleys, deltas, and lake beds, all of which indicate that water once flowed freely on the Martian surface. In 2004, NASA's Opportunity rover discovered clear signs that water had once existed on Mars in the form of sulfate minerals, which only form in the presence of liquid water. Later missions, such as Curiosity, found further evidence of ancient lakes and rivers, providing strong clues that Mars may have been habitable in the past. More recently, in 2018, scientists detected what appears to be a large subsurface lake of liquid water beneath Mars' southern polar ice cap. This discovery, made using radar data from the Mars Express orbiter, has sparked excitement, as underground water could provide a potential habitat for life. While the conditions in this subsurface lake are likely extreme, cold, salty, and high in pressure, it raises the possibility that microbial life could exist below the planet's surface. Additionally, Mars is home to large deposits of water ice just below the surface, particularly near the poles. NASA's Phoenix lander even uncovered water ice just centimeters below the surface in 2008. This ice could provide a future resource for human explorers or even serve as a habitat for life forms that can survive in extreme environments, similar to Earth's polar extremophiles. Mars rovers, uncovering the red planet's secrets. Over the past few decades, several robotic missions have explored Mars, providing unprecedented insights into the planet's geology, climate, and potential for life. NASA's Viking missions in the 1970s were the first to land on Mars and search for signs of life, though their experiments yielded no conclusive evidence. Since then, a fleet of orbiters, landers, and rovers have studied Mars in detail. NASA's Curiosity rover, which landed on Mars in 2012, has been exploring Gale Crater, an ancient lake bed, searching for conditions that might have been favorable for life. Curiosity has found evidence of organic molecules, carbon-based compounds that are essential for life, preserved in Martian rocks, adding to the growing body of evidence that Mars once had the right conditions to support life. In 2021, NASA's Perseverance rover arrived on Mars, carrying with it new tools to search for signs of ancient life. Perseverance is exploring Jezero Crater, a region that scientists believe was once home to a lake and river delta. This crater contains clays and minerals that could have trapped and preserved ancient microbial life. In addition to searching for biosignatures, Perseverance is collecting samples of Martian rock and soil, which will eventually be returned to Earth by future missions for detailed analysis, a critical step in determining whether Mars was ever home to life. Perseverance also carries the Ingenuity helicopter, the first aircraft to fly on another planet. Ingenuity's successful test flights have demonstrated the feasibility of aerial exploration on Mars, paving the way for future missions that might explore areas inaccessible to rovers. The search for life, present and past. The discovery of liquid water beneath Mars' surface, along with organic molecules and evidence of ancient lakes and rivers, has fueled speculation that life could still exist on Mars, even if only in microbial form. While the surface of Mars is harsh and exposed to radiation, the subsurface could offer a more stable environment where life could thrive. On Earth, extremophiles, organisms that survive in extreme environments, offer a model for how life might exist on Mars. Some microbes on Earth thrive in environments that are acidic, salty, or devoid of sunlight, such as deep-sea hydrothermal vents or the frozen lakes of Antarctica. These microbes have adapted to survive in conditions that were once thought to be uninhabitable, giving scientists hope that life could exist in similar niches on Mars. Additionally, methane has been detected in Mars' atmosphere in small, fluctuating amounts. Methane is a gas that, on Earth, is largely produced by biological processes, though it can also be generated by geological activity. The presence of methane on Mars raises the intriguing possibility that microbial life could be producing the gas, though further study is needed to determine whether the source is biological or geological. Future missions to Mars, such as ExoMars, a joint mission between the European Space Agency (ESA) and Russia's space agency Roscosmos, aim to drill deep beneath the Martian surface to search for signs of life. ExoMars rover Rosalind Franklin is equipped with a drill capable of reaching depths of 2 meters, where scientists believe life might still be preserved in the Martian soil. Mars and human exploration, preparing for the future. While the search for life on Mars is a major scientific goal, The red planet also holds a special place in our plans for human exploration. NASA's Artemis program, which aims to return humans to the moon by the mid-2020s, is seen as a stepping stone for sending astronauts to Mars. One of the biggest challenges for human missions to Mars is the planet's thin atmosphere and lack of easily accessible resources. However, scientists and engineers are developing technologies that could make long-term human exploration feasible. For example, NASA's Perseverance rover is testing a technology called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, which converts carbon dioxide from the Martian atmosphere into oxygen. This technology could one day allow astronauts to produce breathable air or even rocket fuel from Mars' natural resources, reducing the need to bring everything from Earth. Moreover, the discovery of water ice on Mars is seen as a potential resource for future explorers. Water could be used for drinking, growing food, and even producing fuel through electrolysis, where water is split into hydrogen and oxygen. The idea of sending humans to Mars, once confined to science fiction, is becoming increasingly realistic. Private companies like SpaceX, led by Elon Musk, have ambitious plans to establish a permanent human presence on Mars within the next few decades. While significant technological and logistical challenges remain, the dream of humans setting foot on the red planet is closer to becoming a reality than ever before. Is Mars the next frontier for life? Mars, with its intriguing geological history, evidence of ancient water, and potential for life beneath its surface, continues to be one of the most promising targets in the search for extraterrestrial life. While we have yet to find definitive proof of life on Mars, each new discovery brings us one step closer to answering the question: has life ever existed on Mars, or could it still exist today? As missions continue to explore the red planet, both robotically and eventually with human explorers, Mars may hold the key to understanding not only the possibility of life beyond Earth, but also the future of humanity's role as an interplanetary species. Chapter 7. The Fermi Paradox. Where is everybody? The universe is vast, so vast that it's nearly impossible to comprehend its scale. Our Milky Way galaxy alone contains billions of stars, many of which are orbited by planets that could, theoretically, support life. If the cosmos is teeming with stars and planets, many of them far older than our own solar system, then the question arises, where is everybody? This is the essence of the Fermi Paradox, one of the most puzzling questions in the search for extraterrestrial life. It was first posed in 1950 by physicist Enrico Fermi during a casual lunchtime conversation with colleagues. Given the size and age of the universe, Fermi wondered why, if intelligent civilizations exist, we haven't seen any definitive evidence of them. If there are other advanced civilizations, why haven't we detected their signals, encountered their spacecraft, or seen other signs of their existence? The Fermi paradox highlights the disconnect between the high probability of extraterrestrial life and the lack of observable evidence. In this chapter, we'll explore possible explanations for the paradox and the implications it has for the search for life beyond Earth. The scale of the universe, why we expect to find life. To understand the Fermi paradox, we must first grasp the scale of the universe and the likelihood of life existing elsewhere. Our solar system is just one of an estimated 100 to 400 billion star systems in the Milky Way galaxy. Beyond that, the observable universe contains roughly 2 trillion galaxies, each with billions of stars. Given these numbers, the probability that Earth is the only planet capable of supporting life seems incredibly low. Moreover, the conditions for life, liquid water, a stable atmosphere, and essential chemicals, appear to be common throughout the universe. As we discussed in earlier chapters, exoplanets' inhabitable zones have been discovered in increasing numbers, suggesting that the ingredients for life may be widespread. If intelligent life has evolved on other planets and developed advanced technology, some civilizations should, theoretically, have had enough time to explore the galaxy or send signals across space. After all, our galaxy is over 13 billion years old, and some of its stars and planets are billions of years older than our solar system. With so much time and space, even a modestly advanced civilization should be detectable, either through direct contact or indirect signs like radio signals. Yet, despite the high probability, we have seen no clear evidence of such civilizations. This contradiction between the high likelihood of extraterrestrial life and the lack of observable evidence is what makes the Fermi paradox so compelling. The Great Silence. Possible explanations for the Fermi paradox. There are many possible explanations for the Fermi paradox, ranging from the optimistic to the unsettling. Let's examine some of the most popular theories. 1. We're not looking in the right way. One of the simplest explanations is that we may not be using the right methods to search for extraterrestrial life. Much of our focus has been on detecting radio signals, as discussed in the previous chapter on SETI. However, it's possible that advanced civilizations don't use radio technology or have moved beyond it. They may communicate in ways we haven't discovered yet, such as through laser signals, quantum entanglement, or other methods that we lack the technology to detect. Additionally, our search has been limited to specific regions of the sky and to a narrow range of frequencies. The universe is so vast that it's possible we've simply missed the signals, or they may be too faint for us to notice. We could also be looking in the wrong time frame. If civilizations are broadcasting signals at intervals of hundreds or thousands of years, we may have just missed their windows of communication. 2. Technological barriers. Another explanation is that civilizations may exist but are unable to reach us due to technological barriers. Interstellar travel is extremely challenging, even for an advanced species. The distances between stars are immense. Proxima Centauri, the closest star to Earth, is over 4 light-years away. Even with the fastest spacecraft we could currently build, it would take tens of thousands of years to reach it. Advanced civilizations might face similar limitations. Even if they have the ability to travel through space, the cost, time, and energy required might make widespread exploration impractical. Civilizations might be content to stay within their own star systems or immediate regions, without attempting to explore the galaxy at large. 3. The zoo hypothesis. One of the more speculative theories is the zoo hypothesis, which suggests that advanced civilizations are aware of us but have chosen not to make contact. According to this idea, extraterrestrials might view Earth as a kind of a zoo or nature reserve, where they observe us from afar without interfering, much like how we study wildlife in natural habitats without revealing our presence. The zoo hypothesis implies that extraterrestrials could be waiting for humanity to reach a certain level of technological or social development before revealing themselves. In this scenario, we are simply not yet advanced enough to warrant contact, or they may be following a strict non-interference policy, similar to the Prime Directive in Star Trek. 4. Civilization self-destruct. One of the more somber explanations is the possibility that advanced civilizations tend to destroy themselves before they can spread across the galaxy. This theory, known as the Great Filter, suggests that there is a critical stage in a civilization's development, such as the discovery of nuclear weapons, climate change, or other forms of self-destruction, that prevents most intelligent species from surviving long enough to achieve interstellar travel or contact. If the Great Filter is real, it could mean that civilizations either never make it past the point of developing advanced technology or that those who do inevitably cause their own extinction. In this context, humanity may be approaching its own Great Filter. If we can overcome the existential challenges of our technological age, we might be able to survive long enough to explore the stars. If not, we could follow the same path to destruction that other civilizations might have taken. 5. We are truly alone. Perhaps the most unsettling explanation is that humanity is alone in the universe. Despite the vastness of the cosmos and the apparent abundance of habitable planets, it's possible that life on Earth is a rare or even unique event. Life may be far more difficult to originate than we currently understand, or the specific conditions that led to life on Earth might be exceedingly rare. If this is the case, the Fermi paradox is not a paradox at all. There simply is no one else to find. While this idea is disheartening, it also places a unique responsibility on humanity. If we are the only intelligent life in the universe, our survival and exploration of the cosmos would take on even greater significance. The implications of the Fermi paradox. The Fermi paradox raises profound questions about humanity's place in the universe. If we are alone, it means that life on Earth is incredibly precious, and our future as a species becomes all the more important. It would suggest that we must safeguard our planet and ensure the survival of our civilization, as we may be the only intelligent beings capable of exploring and understanding the cosmos. On the other hand, if other civilizations exist but are silent or undetectable, it suggests that we still have much to learn about the universe. Perhaps we are on the verge of a great discovery, or perhaps we will eventually make contact when we have the technology and wisdom to understand it. The Fermi paradox also serves as a reminder that, despite our technological advances, we are still at the beginning of our exploration of the universe. We've only scratched the surface of what lies beyond our solar system, and the search for extraterrestrial life is still in its infancy. As our capabilities improve, the chances of solving this paradox increase. What's next? To address the Fermi paradox, scientists are pursuing a range of strategies. Continued investments in projects like SETI, along with new missions to explore the planets and moons in our own solar system, are crucial steps in the search for life. As telescopes become more powerful and capable of detecting biosignatures in the atmospheres of exoplanets, we may one day have the evidence we need to determine whether we are truly alone. Additionally, breakthroughs in fields such as artificial intelligence, machine learning, and quantum computing could help us analyze the massive amounts of data we collect from the universe, making it easier to detect subtle signals that may have gone unnoticed before. In the meantime, the Fermi paradox serves as a thought-provoking mystery, encouraging us to look beyond our own world and consider the broader possibilities of life in the universe. Whether we find answers tomorrow or centuries from now, the search itself reflects our innate curiosity and desire to understand our place in the cosmos. Chapter 8: Extremophiles on Earth. Life in the unlikeliest places. As we continue our search for extraterrestrial life, one of the most important lessons comes from an unlikely source: Earth itself. While much of our planet is teeming with life, thriving in what we consider normal environments, there are places on Earth that are so extreme, so harsh, that they seem utterly inhospitable. Yet in these places life flourishes. Organisms that live in these hostile environments are known as extremophiles. Literally, lovers of extremes. They can survive and even thrive in conditions that would be deadly for most other life forms. The study of extremophiles has revolutionized our understanding of life's resilience and adaptability, expanding the range of environments where we might search for life on other planets. In this chapter, we'll explore the world of extremophiles, examine how they survive in Earth's harshest environments, and consider what they teach us about the potential for life in extreme environments elsewhere in the universe. What are extremophiles? Extremophiles are organisms that have evolved to survive in conditions that would be lethal for most life on Earth. These conditions include extreme temperatures, high levels of radiation, acidic or alkaline environments, and even high pressures found deep below the Earth's surface. Extremophiles belong to various domains of life, including bacteria, archaea, and even some forms of eukaryotes, organisms with complex cell structures like plants and animals. These remarkable organisms have developed special adaptations that allow them to tolerate or even exploit their extreme surroundings. For example, thermophiles thrive in high temperatures, while acidophiles live in highly acidic environments. By studying these organisms, scientists gain valuable insights into the limits of life and expand the range of environments we might consider habitable in our search for life beyond Earth. Types of extremophiles. There are several categories of extremophiles, each adapted to a specific type of extreme environment. Here are some of the most fascinating. 1. Thermophiles and hyperthermophiles, lovers of heat. Thermophiles thrive in extremely high temperatures, often found in environments like hydrothermal vents at the bottom of the ocean, hot springs, or volcanic areas. Hyperthermophiles, a subtype, can survive at temperatures exceeding 80 degrees Celsius 176 degrees Fahrenheit, and some can even thrive at temperatures above 120 degrees Celsius 248 degrees Fahrenheit, far hotter than the boiling point of water. The deep-sea hydrothermal vent bacterium Pyrolobus fumarii, for example, holds the record for living in temperatures as high as 113 degrees Celsius 235 degrees Fahrenheit. 2. Psychrophiles, thriving in the cold. On the opposite end of the temperature spectrum, Psychrophiles are organisms that thrive in extremely cold environments. They can be found in polar ice caps, glaciers, and deep ocean waters. These organisms have evolved proteins and enzymes that remain functional at temperatures below freezing. The discovery of psychrophiles in subglacial lakes in Antarctica has shown that life can exist even in seemingly frozen, inhospitable environments. 3. Acidophiles and alkalophiles, surviving in extreme pH. Acidophiles thrive in highly acidic environments, where the pH can be as low as 1, such as in acid mine drainage or volcanic springs. One well-known acidophile is Acidithiobacillus ferrooxidans, a bacterium that thrives in the acidic waters of abandoned mines. On the other hand, alkalophiles prefer highly alkaline environments, such as soda lakes, where the pH can reach as high as 11. Both types of organisms have adapted their cellular structures and enzymes to maintain function in extreme pH conditions. 4. Halophiles, living in salt. Halophiles are organisms that thrive in environments with high concentrations of salt, such as salt flats, salt lakes, or even evaporating seawater. Some of the most well-known halophiles live in the Dead Sea and Utah's Great Salt Lake. These organisms have developed unique mechanisms to prevent dehydration and maintain cellular balance in environments that would otherwise cause most cells to shrivel and die. 5. Barophiles, thriving under pressure. Barophiles, also known as piezophiles, live under extreme pressure, often found in the deep ocean at depths where the pressure can exceed 1,000 times that of the surface. These organisms have evolved membranes and enzymes that function optimally under crushing pressures, such as those found in the Mariana Trench, the deepest part of Earth's oceans. 6. Radiophiles, tolerating high radiation. Radiophiles are organisms that can withstand high levels of radiation, far beyond what would be lethal to humans. One of the most famous radiophiles is the bacterium Deinococcus radiodurans, which can survive doses of radiation 1,000 times higher than those that would kill a human. Scientists believe this organism's ability to repair DNA damage is key to its resilience, offering intriguing possibilities for how life might survive on planets bombarded by cosmic radiation. Extremophiles and the search for extraterrestrial life. The study of extremophiles on Earth has expanded the range of environments we now consider possible habitats for extraterrestrial life. Before discovering extremophiles, scientists focused on searching for life in environments similar to Earth's temperate regions, where liquid water is present and conditions are stable. However, extremophiles have shown us that life can survive in much more extreme environments, and these revelations have reshaped how and where we look for life beyond Earth. Mars, potential for life below the surface. Mars, as we explored in the previous chapter, has a cold and arid surface, bombarded by radiation from space. However, extremophiles have demonstrated that life doesn't need to thrive on the surface. It can exist below. Microorganisms that survive deep beneath Earth's surface, where they are protected from harmful radiation and temperature extremes, offer a potential model for life on Mars. Given the presence of water ice below Mars' surface, combined with evidence of ancient rivers and lakes, it's possible that microbial life could be lurking beneath the Martian soil, just as extremophiles survive below Earth's surface. The discovery of liquid water beneath the ice at Mars' poles, along with fluctuating methane levels in its atmosphere, raises the possibility that Mars could harbor microbial life in its subsurface regions. Europa and Enceladus, oceans beneath ice. Two of the most promising candidates for extraterrestrial life in our solar system are the icy moons Europa, orbiting Jupiter, and Enceladus, orbiting Saturn. Both moons are believed to have vast oceans of liquid water beneath their icy surfaces, kept warm by tidal forces from their parent planets. The discovery of extremophiles in Earth's deep ocean hydrothermal vents has fueled speculation that similar life forms could exist in the subsurface oceans of these moons. On Earth, life thrives near hydrothermal vents despite the absence of sunlight, relying on chemical energy rather than photosynthesis. This has led scientists to consider that similar life forms could exist on Europa and Enceladus, where volcanic activity at the seafloor could provide the necessary energy for life. The plumes of water vapor observed erupting from Enceladus' south pole, and possibly from Europa as well, offer a tantalizing glimpse into the potential for life beneath their icy crusts. NASA's upcoming Europa Clipper mission, set to launch in the 2020s, aims to explore Europa's surface and plumes in greater detail, searching for biosignatures or other evidence of life. The possibility that extremophiles could exist in these alien oceans far from Earth is one of the most exciting prospects in the field of astrobiology. Titan, life in liquid methane. Another fascinating target in the search for life is Saturn's largest moon, Titan. Titan's surface is covered in lakes and rivers, not of water, but of liquid methane and ethane. While methane-based life is purely speculative, the discovery of extremophiles on Earth that can survive in environments rich in hydrocarbons, such as oil reservoirs, has opened up new possibilities. On Titan, the conditions for life are radically different from Earth, with temperatures far below freezing. However, some scientists speculate that life could adapt to such an environment, using methane as a solvent instead of water. If such life exists, it would represent a truly alien form of biology, unlike anything found on Earth. NASA's Dragonfly mission, set to launch in 2027, will explore Titan's surface and atmosphere, seeking clues about its potential for hosting life. What extremophiles teach us about life's resilience? The discovery of extremophiles has radically changed our understanding of life's potential adaptability. These organisms demonstrate that life can persist in the most inhospitable places, challenging our assumptions about the limits of biology. Their existence has broadened the scope of our search for life beyond Earth, allowing us to consider environments previously deemed too hostile. Extremophiles have also highlighted the importance of looking beyond Earth's surface when searching for life. Just as life on Earth can survive deep underground or at the bottom of the ocean, it's possible that life on other planets or moons could be hiding beneath ice, rock, or even deep within atmospheres, shielded from extreme surface conditions. As we continue to explore our solar system and beyond, extremophiles offer a roadmap for understanding how life might arise and thrive in the most unexpected places. Their remarkable resilience reminds us that life, once it begins, finds a way to adapt, evolve, and survive, even in the harshest conditions. Conclusion: Extremophiles and the future of astrobiology. Extremophiles are living proof that life can survive and thrive in environments far beyond what we once thought possible. Their existence on Earth suggests that life could exist elsewhere in the universe, even in places with extreme temperatures, high radiation, or crushing pressures. By studying extremophiles, scientists are expanding the range of environments they consider habitable, both within our solar system and on exoplanets light years away. As missions to Mars, Europa, Enceladus, and Titan progress, we may one day discover life forms that have adapted to environments previously deemed too extreme. Extremophiles have taught us that the limits of life are far more flexible than we once believed, and the search for extraterrestrial life is just beginning. Chapter 9: The Ethics and Consequences of First Contact. The moment we make contact with extraterrestrial life, whether it's through a distant radio signal or a direct encounter, will likely be the most transformative event in human history. Such a discovery would answer one of the deepest and oldest questions humanity has ever asked. Are we alone in the universe? But with this revelation comes a host of ethical dilemmas and profound consequences, both for humanity and for the extraterrestrial beings we might encounter. What would happen if we found ourselves face to face with intelligent beings from another world? How would we communicate, and what would be the political, cultural, and social ramifications of such an encounter? The questions surrounding the ethics of first contact are as vast as the universe itself, and the answers remain elusive. The nature of first contact. What are we preparing for? First contact could take many forms, and the nature of the encounter would dramatically shape its ethical and societal impact. Would we receive a signal from a distant, advanced civilization, one so far away that direct interaction would be impossible? Or would we discover microbial life on a nearby planet, like Mars or Europa, igniting debates about contamination and planetary protection? Perhaps the most dramatic scenario would be an encounter with an alien spacecraft or intelligent beings visiting Earth. Each of these possibilities carries its own set of ethical challenges. The discovery of microbial life might be primarily a scientific and philosophical issue, while direct contact with intelligent extraterrestrials could shake the very foundations of our global society. Regardless of how contact occurs, the implications are profound. We would need to consider not only how we respond but also how the extraterrestrials might perceive us. Would they see humanity as a potential ally, a curiosity, or a threat? Would they be benevolent, indifferent, or hostile? These are questions that have long been explored in science fiction, but real-world answers remain speculative at best. The ethical dilemma: how should we approach extraterrestrial life? If we were to encounter intelligent extraterrestrial life, one of the first ethical questions would be, how do we engage with them? Do we have the right to initiate contact? The ethics of such interactions are complex and depend on how we define the rights of extraterrestrial beings. Do we treat them as equals with their own inherent rights, or do we approach them as potential resources, much like explorers of the past treated new lands and peoples? This dilemma has deep historical roots in humanity's own colonial past. When European explorers encountered indigenous populations in the Americas, Africa, and other regions, the resulting interactions were often violent, exploitative, and devastating for the indigenous peoples. Many ethicists argue that we must learn from these mistakes and approach any potential contact with extraterrestrials with caution, humility, and respect. One concern is the possibility of cultural contamination. Just as indigenous cultures were often irrevocably changed by contact with technologically superior colonizers, so too might an alien civilization be impacted by humanity's knowledge, technology, or beliefs. If we are the more advanced species in the encounter, we must consider the consequences of introducing our ways of life to another civilization. Could we unintentionally harm them? Would we impose our own values or systems on them, much as humans have done to each other throughout history? Conversely, if we were to encounter a more advanced civilization, how would we protect our own cultural identity? Would humanity remain intact in the face of potentially overwhelming alien technologies and ideologies? The idea of cultural preservation, both for us and for any extraterrestrials we meet, is central to the ethics of first contact. Planetary protection, preserving both worlds. The search for life has so far focused on planets and moons within our solar system, especially Mars, Europa, and Enceladus. But what if we discover microbial life on one of these worlds? How do we ensure that we don't contaminate these ecosystems with Earth-based organisms? Planetary protection is a critical ethical issue in astrobiology. Space agencies like NASA and ESA follow strict guidelines to prevent contamination when sending spacecraft to other planets. These guidelines ensure that we do not introduce Earth life to other worlds, which could potentially destroy or alter native ecosystems before we even know they exist. But planetary protection works both ways. If we bring back samples from Mars or another celestial body, how do we ensure that we don't inadvertently introduce alien microbes to Earth? Such a scenario could pose unknown risks to our biosphere, and the consequences of contamination could range from benign to catastrophic. Protecting both Earth and any extraterrestrial life forms we encounter requires careful, deliberate action, and possibly difficult decisions about whether or not we should even attempt direct contact with alien life. The impact on society, global reactions to first contact. The discovery of extraterrestrial life would trigger a global response unlike any event in human history. If we received a message from an advanced civilization, or even confirmed the existence of simple microbial life on another planet, the cultural, religious, and political ramifications would be profound. Culturally, humans have long viewed ourselves as the center of the universe. The Copernican revolution in the 16th century shattered the notion that Earth was the center of the cosmos, but many of our cultural narratives still assume that humanity is unique. The discovery of alien life would challenge this deeply ingrained belief. Religions around the world would need to reinterpret their teachings in light of the new understanding that we are not alone. How would different belief systems accommodate the idea of intelligent beings from other worlds? Would such a discovery unite us as a species, or further divide us? Politically, the discovery of extraterrestrial life would likely provoke a range of reactions. Governments would need to decide how to handle such knowledge, particularly if contact was made with an intelligent civilization. Would nations work together to respond, or would they compete for resources, knowledge, and potential alliances with extraterrestrials? History suggests that competition, rather than cooperation, might dominate the initial response. The consequences of a fragmented or confrontational approach to first contact could be disastrous, both for humanity and for any extraterrestrials involved. There is also the issue of public reaction. The prospect of contact with extraterrestrials has long fascinated the public, but the reality of such an event might provoke fear, panic, or even violence. How governments and institutions communicate with the public about the discovery of extraterrestrial life will be crucial in shaping the global response. Transparency, education, and a commitment to peaceful engagement will be essential to avoid mass hysteria or misunderstandings. The consequences of first contact. A new era for humanity. If we do make contact with extraterrestrial intelligence, the consequences for humanity will extend far beyond the immediate response. Such a discovery could fundamentally change how we view ourselves and our place in the universe. We would no longer be the only known intelligent species, and that realization could trigger profound changes in our collective worldview. Philosophically, the discovery of extraterrestrial life could lead to a rethinking of humanity's purpose. Are we just one of many intelligent species, destined to play a small role in a much larger cosmic drama? Or does our uniqueness as intelligent beings on Earth give us a special responsibility to each other, to our planet, and to any life forms we encounter? On a practical level, contact with an advanced civilization could accelerate human technological development. We might gain access to knowledge and technology far beyond our current capabilities, revolutionizing everything from medicine to space travel. However, this raises ethical concerns about the potential for misuse. Would these advances be shared equally, or would they exacerbate existing inequalities and conflicts on Earth? Could such technologies be weaponized, leading to new forms of warfare or domination? Ultimately, the consequences of first contact, whether with microbial life or intelligent civilizations, will depend on how we choose to respond. Will we approach the unknown with curiosity, respect, and cooperation? Or will fear, greed, and division define our interactions with extraterrestrial life? Preparing for first contact, looking to the future. As we continue to explore space and search for life beyond Earth, it's essential that we prepare for the possibility of first contact. This preparation involves not only developing the technology to detect and communicate with extraterrestrial civilization, but also addressing the ethical, cultural, and political challenges that will arise. International cooperation will be key. Just as climate change and other global challenges require collaboration, so too will the discovery of extraterrestrial life. The United Nations, space agencies, and international organizations will need to establish frameworks for how humanity engages with alien civilizations, ensuring that the interests of all people, and potentially the extraterrestrials themselves, are respected. At the same time, we must remain cautious. While the discovery of life beyond Earth would be an extraordinary scientific achievement, it could also bring unforeseen risks. Protecting Earth's biosphere, preserving cultural identities, and preventing conflict will be critical as we navigate this new frontier. As we look to the stars, the possibility of first contact reminds us that we are part of a vast and mysterious universe. Whether or not we are alone, the search for life beyond Earth has already begun to reshape how we see ourselves. And when the day comes that we meet another intelligent species, it will mark the beginning of a new chapter in the story of humanity. Chapter 10. The Future of Our Search. What's next? As humanity continues to push the boundaries of exploration, the search for extraterrestrial life is poised to enter an exciting new phase. Advances in technology, along with a deeper understanding of where and how life might exist beyond Earth, are driving the next wave of scientific missions and innovations. Whether it's through interstellar travel, advanced telescopes, or new exploration missions within our own solar system, the question of whether we are alone in the universe is closer than ever to being answered. In this final chapter, we'll explore what the future holds for the search for extraterrestrial life, from cutting-edge technology to upcoming missions. We'll look at how humanity's growing knowledge and capabilities are positioning us to make one of the most profound discoveries in history, the detection of life beyond our planet. Next-generation telescopes, a clearer view of distant worlds. One of the most critical tools in the search for extraterrestrial life is the telescope, and in the coming years, we are set to witness a revolution in our ability to observe distant stars and planets. Telescopes such as the James Webb Space Telescope, JWST, launched in 2021, and other upcoming observatories like LUVOIR, Large Ultraviolet Optical Infrared Surveyor, and HABEX, Habitable Exoplanet Observatory, promise to transform our understanding of the universe. The JWST, for example, is designed to look deeper into space and further back in time than any previous telescope. It has the capability to study the atmospheres of exoplanets, searching for key biosignatures, gases like oxygen, methane, and carbon dioxide that could indicate the presence of life. The ability to analyze the chemical composition of distant worlds is a game changer in astrobiology, offering a direct method of detecting the conditions necessary for life. These next-generation telescopes will not only focus on distant exoplanets but also on our own solar system, where they will study the moons of Jupiter and Saturn, particularly Europa and Enceladus, for signs of life. Their advanced capabilities will help scientists answer the most pressing questions about these icy moons, including whether liquid oceans beneath their surfaces could support life. Additionally, telescopes like the Square Kilometre Array, SKA, an enormous radio telescope project being developed in Australia and South Africa, will dramatically increase the sensitivity of our search for extraterrestrial signals. With the SKA, SETI researchers will be able to scan vast portions of the sky for faint, distant signals that might otherwise go undetected. Together, these instruments represent humanity's most ambitious effort yet to detect alien life. Robotic explorers, reaching out to our neighbors. While telescopes allow us to look deep into space, robotic explorers will be critical for probing the worlds in our own solar system where life might exist. Mars, Europa, and Enceladus remain key targets, and upcoming missions will push our understanding of these planets and moons to new heights. On Mars, NASA's Perseverance rover is already on the surface, searching for signs of ancient life and collecting samples that will eventually be returned to Earth. This Mars sample return mission, slated for the late 2020s, could provide definitive answers about whether microbial life ever existed on the red planet. Scientists will analyze these samples with sophisticated equipment on Earth, potentially uncovering evidence of past or present life. Meanwhile, Europa, Jupiter's icy moon, will be explored in detail by NASA's Europa Clipper mission, scheduled for launch in the mid-2020s. The spacecraft will make multiple flybys of Europa, mapping its surface, studying its ice shell, and searching for clues about the liquid ocean believed to lie beneath. If life exists on Europa, it may be in the form of microbes living in the deep ocean, potentially near hydrothermal vents, similar to those found in Earth's oceans. Enceladus, Saturn's moon, is another promising candidate. With its plumes of water vapor and organic compounds erupting from its surface, Enceladus offers a rare opportunity to study material from a subsurface ocean without having to drill through ice. Future missions to Enceladus, like Enceladus Life Finder, proposed, or other exploratory spacecraft, could further investigate these plumes, searching for signs of life hidden in the moon's subsurface waters. Robotic missions, whether orbiters, landers, or rovers, provide us with unprecedented access to these alien worlds. As technology continues to improve, these missions will become more capable of carrying out complex tasks, such as drilling deeper into ice or soil, or even bringing samples back to Earth. Robotic exploration will remain at the forefront of the search for life in our solar system for years to come. Interstellar exploration, beyond the solar system. While the search for life within our solar system is well underway, the dream of exploring beyond it is still in its infancy. Interstellar travel, reaching stars beyond our own, remains a formidable challenge. The vast distances between stars, combined with the limitations of our current propulsion technologies, make it unlikely that we will send human explorers to another star system anytime soon. However, innovative projects are in development that aim to break through these barriers. One such initiative is Breakthrough Starshot, an ambitious project funded by Russian billionaire Yuri Milner. The goal of Breakthrough Starshot is to send a fleet of tiny, lightweight probes, powered by laser-driven sails, to Proxima Centauri, the closest star system to Earth, located about 4.2 light-years away. These probes, traveling at up to 20% of the speed of light, could reach Proxima Centauri in about 20 years, sending back images and data about its planets, including the potentially habitable exoplanet Proxima Centauri b. While Breakthrough Starshot represents a technological leap, it is the beginning of humanity's efforts to explore beyond our solar system. Future advancements in propulsion technology, such as nuclear fusion or antimatter drives, may one day make interstellar travel a reality. As our knowledge of exoplanets grows, so too will our desire to explore them firsthand, whether through robotic missions or, eventually, crewed spacecraft. Artificial intelligence and machine learning, unlocking the universe's secrets. Another key factor in the future of the search for extraterrestrial life is the role of artificial intelligence, AI, and machine learning. The sheer volume of data collected by telescopes, satellites, and space missions is staggering, and analyzing this data manually would be impossible. AI and machine learning are being used to sift through this vast amount of information, identifying patterns, signals, and anomalies that human observers might miss. In SETI, for example, machine learning algorithms are being developed to detect subtle signals in radio and optical data, filtering out the noise of space to find potential signs of extraterrestrial technology. AI is also being used to process the data from missions like Kepler and TESS, helping scientists identify promising exoplanets in the habitable zones of their stars. As AI continues to advance, it will play an increasingly important role in our search for life beyond Earth. Whether it's automating data analysis, guiding robotic explorers, or even helping design the next generation of space missions, AI will be an indispensable tool in unlocking the secrets of the universe. The role of private industry, expanding humanity's reach. The rise of private space exploration companies like SpaceX, Blue Origin, and Rocket Lab is another game changer for the search for extraterrestrial life. These companies are pushing the boundaries of what is possible in space travel, from reusable rockets to ambitious plans for crewed missions to Mars. SpaceX, led by Elon Musk, has set its sights on colonizing Mars, with plans to send humans to the Red Planet within the next decade. Musk's vision for a self-sustaining human colony on Mars represents a bold step forward in humanity's exploration of space. While the primary goal is to ensure the survival of humanity, the colonization of Mars would also advance the search for life. With humans on Mars, we could explore the planet more thoroughly and rapidly than ever before, potentially discovering signs of life beneath its surface. Private industry is also playing a role in the development of new space technologies, from more efficient propulsion systems to advanced habitats for long-duration space travel. As these companies continue to innovate, they are likely to accelerate humanity's progress in exploring the solar system and beyond. The philosophical questions: what if we find life? While technology and missions are essential to the search for life, the discovery of extraterrestrial life, whether microbial or intelligent, raises profound philosophical questions. How would the discovery of life beyond Earth change our understanding of our place in the universe? Would it unite humanity or further divide us? If we find microbial life on Mars or Europa, it would confirm that life is not unique to Earth. Such a discovery would suggest that life could be common throughout the universe, emerging wherever the conditions are right. This would challenge long-held assumptions about the rarity of life and force us to rethink our understanding of biology, evolution, and the potential for life in extreme environments. The discovery of intelligent extraterrestrial civilizations would have an even greater impact. It would raise ethical questions about how we engage with other intelligent species, and what responsibilities we have to them, and to ourselves. Would we be able to coexist peacefully, or would fear and mistrust dominate the interaction? How would our religious, cultural, and political institutions respond to the knowledge that we are not alone? The search for extraterrestrial life is not just a scientific endeavor, It is a quest that touches on the deepest questions of human existence. As we move forward, it is essential that we consider the broader implications of what we might find, and prepare ourselves for the possibility that we are not the only intelligent beings in the universe. Conclusion: the next frontier. The future of the search for extraterrestrial life is bright, filled with technological innovation, scientific discovery, and the promise of uncovering one of the greatest mysteries of all time. As we build more powerful telescopes, send robotic explorers to distant worlds, and develop the capability for interstellar travel, we are pushing ever closer to the moment when we might finally answer the question: are we alone? The search will take us to the farthest reaches of the cosmos and the most extreme environments in our own solar system. It will challenge our understanding of life and force us to confront new ethical and philosophical questions. But as we continue this journey, one thing is certain: our quest to find life beyond Earth is not just about solving a mystery, it's about understanding our place in the vast, interconnected universe. The next frontier in the search for extraterrestrial life awaits us. Whether the discovery happens tomorrow or centuries from now, we will continue to reach out, driven by the hope that somewhere out there life is waiting to be found. Conclusion: fact, fiction, or somewhere in between. The search for extraterrestrial life has taken us from ancient myths and legends to the cutting edge of modern science. It is a journey that spans thousands of years, from early speculation about life on other worlds to the sophisticated space missions and telescopes of today. Yet, despite all our technological advancements and scientific progress, the answer to the question, "Are we alone in the universe?" remains elusive. The possibility of life beyond Earth is a tantalizing mixture of fact and fiction. The discovery of extremophiles on Earth, the detection of thousands of exoplanets in habitable zones, and the growing evidence of water beneath the surfaces of Mars, Europa, and Enceladus all point to the real possibility that life could exist elsewhere. These facts provide a scientific foundation for the search, reinforcing our belief that we might one day find microbial or even intelligent life beyond our planet. At the same time, fiction has played a critical role in shaping how we imagine extraterrestrial life. From H.G. Wells' The War of the Worlds to the blockbuster films and TV shows of today, fiction has explored every conceivable scenario of first contact, alien invasion, and peaceful coexistence. These stories capture our imagination, giving life to the possibilities that science is still working to prove or disprove. But what if the truth lies somewhere in between? The scientific reality, moving closer to an answer. In many ways, we are closer than ever to answering the question of whether life exists beyond Earth. The rapid pace of discovery in astrobiology, the continuous stream of exoplanet findings, and the development of next-generation telescopes mean that we are gathering more data than ever before. Each new mission, whether it's to Mars, Europa, or distant exoplanets, brings us one step closer to solving the mystery. Yet, we must also acknowledge the immense challenges that remain. The vastness of space, the limitations of our current technology, and the unknown variables in how life might evolve on other planets all make the search difficult and uncertain. We may detect a promising signal or find evidence of past life on Mars, but definitive proof of extraterrestrial life could still be years, decades, or even centuries away. As we move forward, it's important to maintain both our scientific rigor and our sense of wonder. The search for extraterrestrial life is not just about finding microbes or hearing alien radio signals. It's about exploring the limits of what we know and expanding our understanding of the universe. The ethical and philosophical questions. What if we're not alone? Beyond the scientific quest, the discovery of extraterrestrial life, whether microbial or intelligent, would have profound ethical and philosophical implications. How we choose to engage with life on other worlds will reflect our values as a species. Will we approach it with humility and respect, or will we repeat the mistakes of our colonial past, viewing extraterrestrial life as something to be exploited or dominated? If we are not alone in the universe, we must ask ourselves what that means for humanity's sense of identity and purpose. How will our religions, cultures, and societies adapt to the knowledge that we are part of a much larger cosmic community? Will such a discovery bring us together, or will it divide us further as we grapple with the implications of sharing the universe with other intelligent beings? These are not easy questions, but they are ones we must begin to consider as we stand on the threshold of one of the greatest discoveries in history. The possibility of silence. What if we are alone? While the possibility of discovering life beyond Earth excites our imagination, we must also confront the possibility that we may be alone. Despite the billions of stars and planets in the universe, it is possible that Earth is the only place where life has taken hold. If this is the case, it would make life on Earth even more precious. The fragility and uniqueness of life on our planet would take on new significance, and humanity would bear an even greater responsibility to protect and preserve the biosphere. The realization that we are alone in the universe would be both humbling and awe-inspiring, forcing us to reflect on the rarity of our existence and the importance of sustaining life on our planet. Hope for the future. The search continues. Despite the uncertainties and challenges, the search for extraterrestrial life is a journey of hope. It reflects our deepest desire to understand the universe and our place within it. Every discovery, whether it's a new exoplanet in the habitable zone or a microbial fossil on Mars, adds to the growing body of evidence that life may exist beyond Earth. The search is far from over. With each new generation of scientists, explorers, and visionaries, humanity moves closer to finding the answer. Whether we discover life in our solar system, detect a distant signal from a far-off star, or build the technology to travel to other worlds, the quest will continue. In the end, the search for extraterrestrial life is not just about solving a scientific mystery, it's about understanding what it means to be human in an infinite universe. Are we the only intelligent beings in the cosmos, or are we part of a larger galactic community, waiting to be discovered? The answers may still lie beyond our reach, but the pursuit of knowledge and the desire to explore will always drive us forward. Fact, fiction, or somewhere in between. As we conclude this exploration, we are left with a sense of wonder. The search for extraterrestrial life, whether it leads to a distant signal or a hidden microbe beneath the ice of a distant moon, is one of the greatest scientific endeavors of our time. It is a journey that blends fact and fiction, science and imagination, caution and hope. While we may not have all the answers yet, we stand at the edge of discovery. The search for extraterrestrial life is far from over, it is just beginning. And as we continue to explore the stars, we carry with us the hope that somewhere out there life is waiting to be found. Mars, the next giant leap for mankind. Written and published by Ciro Ermisai. Feel free to subscribe for more content. Now let's get into the book. Introduction: Humanity's New Frontier. For millennia, humans have gazed up at the night sky, their imaginations captured by the glowing red dot that is Mars. From ancient mythology to modern science fiction, the red planet has long held a special place in our collective consciousness. Now, for the first time in history, we stand on the brink of turning that ancient curiosity into a reality. The next giant leap for mankind isn't just about walking on another planet, it's about expanding the very horizons of human possibility. Mars represents far more than just another destination in the solar system. It's the boldest expression of our drive to explore, to push the limits of what we know and what we can achieve. Reaching Mars would not only demonstrate the incredible advancements in science and technology that we've made in recent decades, but would also pave the way for an entirely new era of space exploration. Beyond that, the mission to Mars challenges us to think deeply about the future of humanity, about survival, adaptation, and the long-term sustainability of our species beyond Earth. But Mars is no easy frontier. The journey to the red planet is fraught with complex scientific, technological, and human challenges. The vast distance, over 200 million kilometers at its farthest, poses significant logistical hurdles, while Mars' harsh environment makes long-term survival difficult. But where there are challenges, there are also opportunities for innovation, collaboration, and new ways of thinking. This book explores what it will take to get humans to Mars and, perhaps more importantly, what it will mean for humanity when we get there. We'll delve into the science behind the mission, the groundbreaking technologies being developed, and the extraordinary people who will make it happen. We'll also consider the profound ethical questions that arise when we consider setting foot on a new world. Questions about who gets to go, what impact we might have on the planet, and how this new chapter in space exploration might shape the future of civilization. In many ways, the mission to Mars is not just about Mars. It's about our collective ambition as a species, our drive to explore, to innovate, and to build a future that extends beyond the boundaries of our home planet. It is a testament to the enduring human spirit of discovery, one that has carried us from the caves to the stars. As you turn the pages of this book, you'll be invited to imagine a future where humans live and work on Mars, where space is no longer the final frontier, but the next step in our journey. Welcome to the new frontier of humanity, Mars. Chapter 1. Why Mars? The science behind the choice. Mars. Of all the celestial bodies in our solar system, why has this red, desolate planet captured the imagination of scientists, explorers, and dreamers alike? Why not Venus, with its similar size and proximity to Earth, or one of the moons of Jupiter or Saturn, which may harbor oceans beneath their icy surfaces? The answer to why Mars is the next frontier for human exploration lies in a combination of factors. Its geological features, its relative accessibility, and the tantalizing possibility that it might have once harbored life, or might even do so now. Planet both familiar and alien. Mars is in many ways both strikingly similar to Earth and dramatically different. It's the planet most like ours in the solar system, with a day that lasts just over 24 hours and seasons that shift with the tilt of its axis, much like Earth's. Its surface is home to valleys, deserts, and polar ice caps. The largest volcano in the solar system, Olympus Mons, and the deepest canyon, Valles Marineris, are both found on Mars. These features make it an intriguing target for study and exploration, offering a landscape that, despite its alien nature, feels oddly familiar. But Mars is also a planet of extremes. Its atmosphere is a thin wisp of carbon dioxide, with less than 1% of the density of Earth's, making it impossible for humans to breathe without assistance. The average surface temperature is a bone-chilling -60 degrees Celsius, -80 degrees Fahrenheit, and powerful dust storms can envelop the planet for weeks at a time. Water, the essential ingredient for life as we know it, exists mostly in frozen form at the poles or locked beneath the surface. Yet, despite these challenges, Mars is uniquely positioned as a candidate for exploration. Unlike Venus, where crushing atmospheric pressure and scorching temperatures make human missions nearly impossible, Mars offers a surface we can actually land on and explore. Unlike the distant moons of the gas giants, Mars is close enough to Earth to be within our reach with current technology, yet far enough to represent a new frontier of discovery: the quest for life. One of the most compelling reasons to explore Mars is the possibility of finding life, or at least evidence that life once existed there. Over the last few decades, robotic missions like NASA's rovers have revealed that Mars was once a very different place. Billions of years ago, it had rivers, lakes, and perhaps even a vast ocean covering much of its northern hemisphere. Where there was water, there might have been life. Today, the search for life on Mars continues, with missions designed to probe the surface and subsurface for signs of microbial life. While the planet's surface is harsh and irradiated, underground environments might offer better protection for life forms. Some scientists speculate that microbial life could still survive in subsurface pockets of water, shielding the planet's harsh surface conditions. Finding life on Mars, or even evidence that it once existed, would be one of the most profound discoveries in human history. It would fundamentally reshape our understanding of biology, evolution, and the uniqueness, or lack thereof, of life on Earth. It could even provide clues about how life on Earth began, offering insights into the conditions that allow life to flourish. Preparing for the future of space exploration. Mars is not just a target for exploration, it's a stepping stone for the broader goal of space colonization. If humans are to live and work beyond Earth, Mars represents the most logical place to start. Its relative proximity to Earth means we can get there within months rather than years. It has the resources, like water, ice, and carbon dioxide, that we can potentially use to create fuel, air, and even building materials. And with its gravity being about 1/3 that of Earth's, it offers a more hospitable environment for long-term human habitation than the airless moon. Mars is also a testing ground for the technologies we will need to explore even further into the solar system and beyond. Establishing a human presence on Mars will require innovations in spacecraft design, life support systems, and sustainable resource utilization. These advances will not only benefit future Mars missions but also pave the way for deeper space exploration, to the moons of Jupiter and Saturn, and perhaps one day to other star systems. Mars as humanity's backup plan. In recent years, the idea of Mars as a backup planet for humanity has gained traction. As Earth faces increasing environmental challenges, from climate change to overpopulation to the potential for natural or man-made disasters, some visionaries see Mars as a potential second home for humans. While this idea is still far from being a reality, the concept of planetary insurance is a powerful motivator for many space exploration advocates. Elon Musk, founder of SpaceX, has famously spoken about making humanity a multiplanetary species, with Mars as the first step. The logic is simple. If something were to happen to Earth, having a self-sustaining human colony on Mars could ensure the survival of our species. This doesn't mean abandoning Earth, but rather expanding our presence in the universe to increase our chances of long-term survival. The challenge is ahead. Of course, the idea of colonizing Mars is not without its critics. The challenges are immense, and some question whether the billions or trillions of dollars required for a manned mission to Mars might be better spent addressing problems here on Earth. There are ethical questions too about the impact humans might have on Mars' environment and the potential contamination of the planet, especially if we find life there. But despite these challenges, the pursuit of Mars remains a powerful symbol of human ambition and curiosity. The journey to Mars is about more than just exploration. It's about pushing the boundaries of what we know and what we're capable of. It's about the desire to reach for the stars and discover what lies beyond the next horizon. Mars is the planet that makes sense scientifically, strategically, and philosophically. It offers the potential for groundbreaking discoveries, both in terms of understanding our place in the cosmos and in pushing the limits of human ingenuity. In the next chapter, we'll delve into the history of Mars exploration, tracing the steps that have brought us to the threshold of this new era of space exploration. Chapter 2: The History of Mars Exploration. The story of Mars exploration begins long before humanity had the technology to send rockets into space. It is a tale that stretches back to ancient civilizations, through centuries of scientific discovery, and into the modern era of robotic missions. The history of our fascination with Mars is one of curiosity, imagination, and relentless pursuit of knowledge. An ongoing journey that has culminated in the real possibility of sending humans to the Red Planet. Ancient observations and early theories. Mars has captivated human beings for thousands of years. Ancient Egyptians were some of the first to observe Mars, tracking its movements across the sky over 3,500 years ago. The Babylonians, Greeks, and Romans also noted the planet's unusual reddish hue, associating it with their gods of war, Ares in Greece, Mars in Rome. This connection with war and conflict persisted across cultures, making Mars a symbol of both mystery and power. Early astronomers struggled to understand the motion of Mars. Unlike the stars, which followed regular patterns, Mars appeared to move erratically, sometimes even seeming to reverse its course in the sky. This phenomenon, known as retrograde motion, puzzled astronomers for centuries. It wasn't until the 16th century when Nicholas Copernicus proposed the heliocentric model of the solar system, with the sun at the center, that we began to understand why. Mars, like Earth, orbits the sun, and its apparent backward motion is simply the result of Earth overtaking Mars in their respective orbits. In the 17th century, the invention of the telescope opened a new chapter in the study of Mars. Italian astronomer Galileo Galilei became the first person to observe Mars through a telescope in 1610, and in the years that followed, astronomers like Christian Huygens and Giovanni Cassini made detailed drawings of the planet's surface, identifying its polar ice caps and speculating about the possibility of water, the Martian canals, and early speculations of life. By the late 19th century, Mars had become a focal point for speculation about extraterrestrial life. Italian astronomer Giovanni Schiaparelli's observations in 1877 led to one of the most enduring and controversial ideas in Mars history, the canals of Mars. Schiaparelli observed what appeared to be long, straight lines crisscrossing the surface of Mars, which he referred to as canali, meaning channels or grooves. However, this term was mistranslated into English as canals, sparking wild speculation that these features were artificial structures built by an advanced Martian civilization. American astronomer Percival Lowell took this idea and ran with it. In the 1890s, Lowell published a series of books arguing that the canals were evidence of intelligent life on Mars. According to Lowell, the canals were part of a vast irrigation system designed to bring water from Mars' polar ice caps to the planet's arid equatorial regions. Although Lowell's theories were eventually discredited as optical illusions, they captured the public imagination and cemented the idea of Mars as a potentially inhabited world in popular culture. This period of speculation also inspired some of the earliest works of science fiction, most notably H.G. Wells' The War of the Worlds, 1898. Wells' vision of a Martian invasion of Earth reflected both the fascination with and fear of the unknown that characterized humanity's relationship with Mars at the time. The idea of life on Mars became a staple of science fiction, from Edgar Rice Burroughs' Barsoom series to Ray Bradbury's The Martian Chronicles. Space age, from flybys to landers. The dawn of the space age in the mid-20th century brought the first real opportunities to explore Mars up close. In 1965, NASA's Mariner 4 spacecraft performed the first successful flyby of Mars, sending back 21 images of its surface. These images shattered many of the romanticized notions of Mars as a world teeming with life. Instead of green vegetation or Martian cities, Mariner 4 revealed a barren landscape covered in impact craters, more akin to the Moon than Earth. Despite this, interest in Mars only grew. NASA's Viking missions of the 1970s marked a major milestone in Mars exploration. Viking 1 and Viking 2 became the first spacecraft to successfully land on Mars, each carrying instruments designed to search for signs of life. While the Viking experiments did not find definitive evidence of biological activity, they provided unprecedented data on Mars' atmosphere and surface conditions. The 1990s and 2000s saw a resurgence in Mars exploration, driven by advances in technology and a renewed interest in the possibility of water and life on Mars. The Mars Global Surveyor, launched in 1996, mapped the entire surface of Mars, revealing evidence of ancient river valleys, lake beds, and flood channels. NASA's Mars Pathfinder mission, which landed in 1997, introduced the world to Sojourner, the first rover to explore the surface of another planet. The era of rovers, a new chapter in exploration. Mars exploration took a giant leap forward in 2004 with the arrival of NASA's twin rovers, Spirit and Opportunity. These robotic explorers were designed to search for signs of past water activity on Mars, and they exceeded all expectations. Opportunity, in particular, far outlasted its intended 90-day mission, exploring the Martian surface for nearly 15 years. It discovered clear evidence that Mars had once been home to liquid water, further fueling the possibility that Mars could have supported life in the past. Following Opportunity's success, NASA's next-generation rover, Curiosity, landed on Mars in 2012. Curiosity was equipped with more advanced scientific instruments, allowing it to analyze the chemical composition of Martian rocks and soil in greater detail. One of Curiosity's key findings was the detection of organic molecules, complex carbon-based compounds that are the building blocks of life. This discovery suggested that Mars may have once had the right conditions for life to arise. In 2021, NASA's Perseverance rover continued the tradition of robotic exploration. Unlike its predecessors, Perseverance is specifically designed to search for signs of ancient microbial life. It is equipped with a drill to collect samples of Martian rock and soil, which future missions may return to Earth for analysis. Perseverance also brought along a small helicopter named Ingenuity, which became the first aircraft to fly on another planet. International efforts and the road ahead. Mars exploration is not limited to NASA. In recent years, space agencies from around the world have joined the quest to unlock the mysteries of the Red Planet. The European Space Agency, ESA, has contributed with missions like the Mars Express Orbiter, which continues to study Mars' atmosphere and geology. India's space agency, ISRO, successfully launched its Mars orbiter mission in 2013, becoming the first Asian nation to reach Mars. China's Tianwen-1 mission, launched in 2020, became the first mission to include an orbiter, lander, and rover all in one. The mission's rover Zhurong has been exploring Mars' Utopia Planitia region, further expanding humanity's understanding of the planet. As we look to the future, the next great challenge is clear: sending humans to Mars. Space agencies and private companies alike are working on plans for crewed missions, with NASA's Artemis program and SpaceX's ambitious Starship project aiming to make this dream a reality within the next few decades. A journey of discovery. From ancient observations to modern robotic missions, the history of Mars exploration has been one of continuous discovery. Each new mission has brought us closer to answering the big questions. Did Mars once harbor life? Could it still? And perhaps most exciting of all, what will it take to make Mars humanity's next home? Chapter 3: The Technological Challenges of Reaching Mars. Sending humans to Mars is one of the most ambitious goals humanity has ever pursued. The journey to the Red Planet isn't just about distance. It's about overcoming a vast array of technical and human challenges. While robotic missions have given us valuable insights into Mars, sending humans there is a different level of complexity. It's not only about the rockets that get us there, but also about keeping people alive for months in space and on a planet that's hostile to life as we know it. In this chapter, we'll dive into the technical hurdles that must be cleared before the first human sets foot on Mars. These challenges test the limits of our current technology and require innovations in everything from propulsion systems to life support and habitat construction. As daunting as these obstacles may seem, progress is being made, bringing humanity ever closer to this monumental achievement. The distance problem. The most immediate challenge of reaching Mars is the sheer distance between Earth and the Red Planet. Unlike the Moon, which is a mere 384,000 kilometers away, Mars can be over 200 million kilometers from Earth, depending on the alignment of the planets. This means that, even with the fastest rockets we have today, a one-way trip to Mars would take between 6 and 9 months. That's 6 to 9 months of astronauts traveling through deep space, cut off from the resources and support systems of Earth. In space, there's no room for error. Every system, from the engines that propel the spacecraft to the equipment that provides food, water, and air, must function perfectly for the entire duration of the mission. The long journey also exposes astronauts to significant risks, including radiation from the sun and cosmic rays, which can damage their health over time. One solution being explored is advanced propulsion systems, such as nuclear thermal propulsion or ion drives, which could shorten the travel time significantly. These technologies are still in development, but they offer hope for faster and more efficient journeys to Mars. Reducing the time astronauts spend in transit not only lowers their exposure to radiation but also reduces the amount of food, water, and other supplies they would need to bring along, lightening the load on the spacecraft. Radiation, the invisible enemy. Space is not a friendly environment for human life. Beyond Earth's protective magnetic field and atmosphere, astronauts are exposed to high levels of cosmic radiation. On a trip to Mars, this radiation could pose serious health risks, including increased cancer rates and damage to the brain and other organs. Long-term exposure to space radiation is one of the most significant challenges we face in sending humans to Mars. Scientists and engineers are exploring several strategies to mitigate this risk. One approach is to build spacecraft with better radiation shielding, using materials that can block or absorb harmful particles. Some concepts even propose using water or other supplies as shielding, packing them around the crew's quarters to create a protective barrier. Another idea is to develop spacecraft that can generate artificial magnetic fields to mimic Earth's protective bubble, though this technology is still in its infancy. Once on Mars, the radiation problem doesn't go away. Mars lacks a strong magnetic field and has a very thin atmosphere, meaning its surface is constantly bombarded with radiation from space. Any long-term habitats on Mars will need to be built with this in mind, perhaps underground or covered in thick layers of regolith, the Martian soil, to shield the occupants from radiation, sustaining life, air, water, and food. Keeping astronauts alive on the journey to Mars is one thing. Ensuring they survive once they get there is another. Mars' environment is extremely hostile to human life. The planet's atmosphere is composed mostly of carbon dioxide, with only trace amounts of oxygen. The air pressure on Mars is also less than 1% of Earth's, meaning astronauts won't be able to step outside without wearing pressurized suits. One of the most critical challenges is providing astronauts with a steady supply of oxygen. While we can send oxygen with them from Earth, a long-term mission requires a more sustainable solution. One promising technology is called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, which is designed to produce oxygen from the carbon dioxide in Mars' atmosphere. MOXIE was successfully tested on NASA's Perseverance rover and could pave the way for larger systems capable of supporting human life. Water is another essential resource. While Mars has water ice at its poles and potentially in underground reservoirs, it's not as readily accessible as it is on Earth. Future missions will need to develop ways to extract, purify, and store water on Mars. Technologies that recycle water, such as those used on the International Space Station, will also play a crucial role. As for food, growing crops on Mars presents a significant challenge. The Martian soil is not ideal for farming, lacking the nutrients that plants need to thrive. However, researchers are working on ways to modify the soil and use hydroponic or aeroponic systems, which allow plants to grow without soil, using nutrient-rich water or air. These systems could provide a sustainable source of food for future Martian settlers. The challenges of transportation and landing. Getting to Mars is one thing, but landing on the planet presents a whole new set of challenges. Mars' thin atmosphere makes landing much more difficult than on Earth. While there's enough atmosphere to create friction and heat during descent, it's not thick enough to slow down a spacecraft effectively. Large parachutes, heat shields, and retro rockets will all need to work in perfect harmony to bring a human mission safely to the Martian surface. Current robotic missions, like the Curiosity and Perseverance rovers, have used sophisticated landing techniques, such as the sky crane system, to lower the rovers onto the surface. However, landing humans and the much larger equipment they will need is a far more complex task. Engineers are working on ways to safely land heavier payloads on Mars, which will be crucial for transporting habitats, vehicles, and supplies. Once on the surface, astronauts will need vehicles to explore the planet and transport equipment. These vehicles must be able to operate in Mars' harsh conditions, including its dust storms and extreme temperatures. They must also be powered by renewable energy, as the ability to bring large amounts of fuel from Earth will be limited. Building a home on Mars. The final piece of the puzzle is constructing habitats where humans can live and work on Mars. These habitats will need to protect astronauts from the planet's extreme cold, low pressure, and radiation. They will also need to be self-sustaining, recycling air, water, and waste to minimize the need for resupply missions from Earth. Several concepts for Martian habitats are being explored, ranging from inflatable structures that can be transported and deployed on the surface, to underground bases carved into Mars' natural landscape. 3D printing technology could also play a role, allowing habitats to be built using materials found on Mars itself, such as regolith. This would reduce the need to transport heavy building materials from Earth, making the mission more feasible and cost-effective. Ultimately, building a base on Mars isn't just about surviving, it's about thriving. The goal is to create an environment where astronauts can live for extended periods, conduct scientific research, and even begin the process of making Mars more habitable for future generations. This could involve everything from growing food to experimenting with new technologies for resource extraction and energy production. The road ahead. Reaching Mars is not just a question of overcoming one big obstacle. It's about solving countless smaller problems, each of which presents its own unique challenges. The technology we're developing today, whether it's advanced propulsion systems, life support innovations, or sustainable habitats, will lay the foundation for humanity's future on Mars. But the journey to Mars is not just a technical challenge. It's a testament to the human spirit of exploration, to our unrelenting desire to push beyond the boundaries of the known world and discover what lies beyond. With every new breakthrough, we move one step closer to making Mars the next home for humanity. Next, we'll look at the detailed planning process that goes into preparing for a mission to Mars. How do scientists and engineers prepare for such an epic journey, and what strategies are being developed to ensure its success? Chapter 4. The First Steps: Mission Planning and Preparation. Sending humans to Mars isn't just a grand vision. It's an intricate dance of logistics, timing, and precision that requires years, even decades, of planning. Every aspect of the mission, from the design of the spacecraft to the landing procedures, must be meticulously prepared and tested. The stakes are incredibly high, and there's little room for error. For Mars, every detail matters. But beyond the technical challenges, there's something deeper driving the mission: the need to ensure that humanity's journey to Mars is not just a one-way trip, but a sustainable venture that could one day open the door to permanent human settlement. In this chapter, we explore how mission planners are tackling this massive undertaking, how they prepare for every contingency, and how the dream of Mars is being translated into concrete action. Launching windows and timing the journey. Mars isn't always within reach. In fact, it only comes close to Earth every 26 months, in an event known as a launch window. During these windows, the orbits of Earth and Mars align in such a way that the distance between the two planets is minimized, making it the ideal time to send spacecraft. Planning a mission to Mars begins with these windows because missing one means waiting another 2 years to try again. Mission planners carefully calculate the trajectory of the spacecraft, using the alignment of the planets to their advantage. This process, known as the Hohmann transfer orbit, allows a spacecraft to slingshot from Earth to Mars, using the least amount of fuel possible. It's a precise calculation where timing is everything, both in leaving Earth and arriving at Mars. A slight miscalculation could result in a spacecraft overshooting the planet or arriving at a time when landing conditions are unfavorable. The launch itself is another crucial moment. Rockets capable of carrying a crew and all their necessary supplies need to be powerful enough to break free from Earth's gravity, while also being able to transport equipment that will keep astronauts alive on the long journey. This requires rockets much larger than those used for previous missions to the Moon or Mars robots, which is why vehicles like NASA's Space Launch System, SLS, and SpaceX's Starship are being developed specifically with Mars in mind. The journey: surviving space. Once the spacecraft is launched and on its way, astronauts face one of the most challenging phases of the mission: the months-long journey through deep space. This voyage is not a simple road trip, but a survival test in one of the most unforgiving environments imaginable. Spacecraft designed for this journey must be equipped with everything the crew needs for survival: air, water, food, power, and protection from space's many dangers. One of the greatest threats during the journey is radiation. Without Earth's atmosphere and magnetic field to protect them, astronauts will be exposed to cosmic rays and solar radiation for an extended period. The spacecraft will need to be shielded from this radiation, and mission planners are also exploring ways to use innovative materials or structures that can offer additional protection, perhaps even using water tanks or supplies as barriers. Life support systems are also a key part of the planning. Astronauts will need a steady supply of oxygen, and waste, whether solid, liquid, or gas, will need to be carefully managed. Every drop of water and every breath of air must be recycled and reused as efficiently as possible, because there's no resupply station in space. Technologies developed for the International Space Station, ISS, which recycles almost all of its water, are being adapted for Mars missions to ensure sustainability. Meanwhile, keeping the crew healthy, both physically and mentally, is another challenge. In the weightless environment of space, muscles and bones weaken, and astronauts need to exercise daily to combat these effects. The isolation and distance from Earth, with no immediate help in case of emergencies, adds a psychological strain. Planners are exploring ways to provide support and comfort for the astronauts, ensuring they stay mentally sharp for the challenges ahead. Landing on Mars, a complex task. Perhaps the most nerve-wracking moment of any Mars mission will be the landing. Getting a spacecraft safely onto the Martian surface has been one of the biggest challenges in space exploration, as evidenced by the mixed success rate of past robotic missions. Mars' thin atmosphere doesn't provide enough friction to slow a spacecraft down as it would on Earth, but there's just enough atmosphere to require heat shielding during descent. This creates a tricky balance for engineers to solve. For humans, landing on Mars will be even more challenging. The spacecraft will be heavier, requiring more sophisticated landing technology. In robotic missions, NASA has experimented with various systems: parachutes, heat shields, and even sky cranes, but these technologies will need to be scaled up significantly to accommodate human missions. One possible solution being developed is using inflatable heat shields that expand as the spacecraft enters the Martian atmosphere. These would increase drag, slowing the spacecraft down without the need for massive parachutes. At the same time, landing systems will need to ensure that the spacecraft can touch down in a safe area, free from boulders or steep slopes, that has been scouted by orbiters or earlier missions. But landing isn't just about touching down, it's about touching down in the right place. Where humans land on Mars will have a major impact on the mission's success. Planners are targeting locations near water ice deposits or areas with geological interest, places where the astronauts can conduct scientific experiments while also ensuring access to essential resources. Staying alive on Mars. Once on Mars, astronauts will face an entirely new set of challenges. The planet's thin atmosphere offers no protection from cosmic radiation, and temperatures can plummet to deadly lows. Mars' gravity is about 1/3 that of Earth's, which will affect how astronauts move, work, and adapt physically over time. And then there's the issue of air. There's none to breathe. To survive, astronauts will need habitats that protect them from the harsh conditions. These habitats must be capable of recycling air and water, generating power, and providing a stable environment for months, if not years. Early habitats may be pre-packaged and transported from Earth, designed to be inflated or assembled on Mars. Others may be built on-site, using materials found on Mars itself, like the planet's abundant dust and rock, through 3D printing or other construction methods. Power is another essential element. Solar panels are the most obvious choice, but Mars receives less sunlight than Earth, and its frequent dust storms can cover panels for weeks at a time. As a result, mission planners are also exploring nuclear power as a reliable backup, ensuring that astronauts have the energy they need, no matter what Mars throws their way. Communication with Earth is another hurdle. Given the vast distance, it can take up to 20 minutes for a signal to travel from Mars to Earth. This means real-time communication isn't possible, and astronauts will need to be highly autonomous, able to solve problems on their own without immediate guidance from mission control. Planning for contingencies. As with any complex mission, one of the most critical parts of the planning process is preparing for the unexpected. What happens if a spacecraft malfunctions en route? What if a key system breaks down while on Mars? How do astronauts deal with a medical emergency millions of kilometers away from Earth? Mission planners are designing the Mars mission with contingencies in mind. Redundancy is key. Every system will have backups, and astronauts will be trained to handle a wide range of scenarios. Moreover, technologies like 3D printing could allow astronauts to manufacture replacement parts on Mars, reducing their reliance on Earth for resupply. Another consideration is the possibility of aborting the mission. While everyone hopes this won't be necessary, it's essential to have a plan for returning to Earth safely, whether that means cutting the mission short or finding ways to extend it until help can arrive. The path forward. The journey to Mars will be humanity's most daring adventure yet, requiring unprecedented levels of preparation, technology, and cooperation. The planning phase is as critical as the mission itself, laying the groundwork for everything that will follow. Every decision made now will determine the success or failure of the mission, and every solution we develop will help build the future of human exploration. We are no longer just dreaming of Mars, we are actively preparing to make it a reality. As the plans come together and technology continues to advance, the path to Mars becomes clearer, with each step bringing us closer to this incredible leap for humankind. Chapter 5. Living on Mars, Habitats, Resources, and Sustainability. Living on Mars will require a combination of ingenuity, technology, and adaptability. The environment is unlike anything we've experienced, and building a self-sustaining presence that will push the boundaries of what we understand about life off Earth. On Mars, the air is too thin to breathe, the temperatures are too cold for human comfort, and the surface is bombarded by radiation. Yet, despite these challenges, the dream of making Mars a home for humanity is alive and achievable. This chapter explores what life on Mars might look like, focusing on how astronauts will build, maintain, and live in habitats designed to protect them from the planet's harsh conditions. It will also examine how we plan to utilize resources to create a sustainable environment where humans can not only survive but thrive. Building a home in a hostile environment. One of the first and most critical challenges is creating habitats that can withstand Mars' extreme conditions. The thin atmosphere offers almost no protection from radiation or meteor strikes, and temperatures can drop to -60 degrees Celsius or lower at night. So, the question is, how do we build a home in such a place? The first step will likely involve prefabricated habitats sent from Earth. These structures will be lightweight, easy to assemble, and designed to be airtight, protecting astronauts from the unbreathable Martian atmosphere. However, these early habitats are just the beginning. For longer-term missions, sustainability is key, and that means using Mars' natural resources to reduce dependence on Earth. Scientists and engineers are exploring the possibility of building with Martian materials. The idea is to use what's already available, namely the planet's abundant soil known as regolith. 3D printing technology could play a crucial role in this effort. By combining Martian regolith with binders, future habitats might be printed layer by layer, creating thick, insulated walls that can protect against radiation and temperature swings. Mars' gravity, which is about 1/3 that of Earth, also impacts how habitats are designed. Structures won't need to support the same weight as they would on Earth, allowing for more innovative designs that could stretch the limits of what we imagine a home on Mars might look like. But habitats aren't just about protection. They must provide everything astronauts need to live. Inside these structures, life support systems will generate oxygen, recycle water, and manage waste. These systems are critical as they will enable astronauts to live semi-independently from Earth, reducing the need for constant resupply missions. Harnessing local resources, the key to sustainability. Perhaps the most exciting aspect of living on Mars is the potential to use the planet's resources to support human life. This concept, known as in situ resource utilization (ISRU), will be central to creating a sustainable presence on Mars. Without it, astronauts would be entirely dependent on supplies from Earth, making long-term missions impractical. Water is one of the most important resources, and there's evidence that Mars has a significant amount of it, though not in liquid form. Much of Mars' water is locked in ice, either at the poles or below the surface. Future missions will likely focus on locating and extracting this water. Once extracted, water can be used for drinking, growing food, and even split into hydrogen and oxygen, which could serve as rocket fuel and breathable air. Mars' atmosphere, while thin, is rich in carbon dioxide. Technologies like the MOXIE experiment, currently being tested on the Perseverance rover, have already shown that we can convert Martian CO2 into oxygen. Scaling up this technology would be essential for providing breathable air in habitats and supporting human life over the long term. The planet's abundant sunlight, despite being weaker than on Earth, can also be harnessed for energy. Solar panels are already being used by rovers and landers, and they will likely be a primary power source for Martian habitats. However, Mars' infamous dust storms, which can last for weeks, pose a challenge for solar energy. To address this, mission planners are exploring backup options, such as nuclear power, which could provide a reliable energy source even during periods of low sunlight. Growing food on Mars, feeding the pioneers. No mission to Mars can succeed without a sustainable food supply. Shipping food from Earth isn't feasible in the long run, so astronauts will need to grow their own food on the red planet. The good news is that scientists are already experimenting with ways to grow crops in environments similar to Mars. Martian soil, while not naturally fertile, could be treated or supplemented with nutrients to support plant life. Experiments on Earth using simulated Martian soil have shown that plants like potatoes and certain grains can grow in this environment, although they need considerable help. Hydroponic farming, growing plants in nutrient-rich water rather than soil, may be a more effective method as it eliminates the need for soil altogether. This method also allows for more control over the growing conditions, which is important in the unpredictable Martian climate. The goal is to create a closed-loop system where food can be grown using recycled water and nutrients from waste products. This kind of self-sustaining ecosystem would be a game-changer for long-term missions, reducing reliance on Earth and allowing astronauts to stay on Mars for extended periods. Astronauts will also need to adapt to a diet based on what can be grown in such an environment. Fresh fruits and vegetables will be a luxury, and meals may consist mostly of grains, legumes, and other crops that are easy to grow in controlled conditions. While this may seem limiting, the psychological benefits of eating fresh, homegrown food on an otherwise barren planet cannot be overstated. The psychological and social challenges of isolation. Living on Mars isn't just a physical challenge, it's a psychological one. The isolation of being millions of kilometers from Earth, in an environment where one mistake could be fatal, will test the mental resilience of astronauts in ways we have never seen before. Communication with Earth will be delayed by up to 20 minutes each way, making real-time conversations impossible. This delay forces astronauts to solve problems independently, relying on their training and each other for support. Moreover, living in close quarters with the same small group of people for months or years can create tension. Mission planners are well aware of the social dynamics that could arise, and crew selection will be critical. The astronauts chosen for Mars will not only need to be highly skilled, but also adaptable with strong communication skills and emotional resilience. To mitigate the psychological effects of isolation, astronauts will likely have access to virtual reality systems that allow them to escape to more familiar environments, even if just for a few minutes a day. They'll also maintain regular contact with family and mission control, albeit delayed, to stay connected with life back on Earth. Creating a sense of purpose and routine will also be essential. Astronauts will be constantly engaged in scientific experiments, maintenance of their habitat, and preparing for exploration missions on the surface. This sense of ongoing discovery and contribution to a greater goal could be one of the key motivators that helps them push through the inevitable difficulties of life on Mars. The first Martians, what life could look like. As we imagine what life on Mars will be like, we must consider that the first humans to live there will be pioneers in every sense of the word. Their experience will be entirely unlike anything we've known before. They will be astronauts, scientists, engineers, and settlers all at once, working not only to survive but also to lay the foundation for a future where humans might one day live on Mars permanently. Every aspect of life on Mars will require adaptation, from how they work to how they sleep, how they interact with each other, and how they cope with the reality of being on a different planet. But these pioneers will also be doing something incredible. They will be the first humans to create a home on another world. While life on Mars will be difficult, it will also be filled with moments of wonder. Imagine standing on the surface of Mars, watching a sunset through the thin, pink-tinged atmosphere, knowing you are farther from Earth than anyone has ever been. Imagine conducting groundbreaking research that could answer some of the most profound questions about life in the universe. These are the experiences that will make the hardships worth it. The road to self-sufficiency. The ultimate goal of living on Mars is not just to survive but to thrive. Over time, habitats will become more advanced, and the need for resupply from Earth will diminish as we master the art of using Mars resources. Eventually, the goal is to establish a self-sustaining colony where humans can live, work, and even raise families. This vision is still a long way off, but every mission to Mars brings us closer. The first steps are about learning how to live in this alien environment, how to build, grow, and adapt. But with each success, we move closer to the day when Mars is not just a place we visit, but a place we call home. Next, we'll look at the psychological and physical impacts that living on Mars could have on astronauts. What does it take, mentally and physically, to thrive on a planet so far from Earth? Chapter 6. The psychological and physical impact on astronauts. Living and working on Mars will not just challenge the mind, it will push the human body and psyche to their limits in ways we've never fully experienced. While technology will play a crucial role in ensuring survival, The true heart of any Mars mission lies in the people sent to live there. These individuals will face months of isolation, an unfamiliar landscape, and the weight of representing all of humanity on a foreign planet. The psychological and physical toll of such an experience will be immense, and understanding and preparing for these impacts will be key to ensuring the mission's success. Mental strain of isolation. One of the most profound challenges astronauts will face on Mars is isolation. 4 months, they will live in confined spaces, cut off from Earth by millions of kilometers and time delays that make real-time communication impossible. Every problem they encounter will need to be solved by the crew, with limited immediate support from mission control. This level of isolation, with no chance of returning to Earth quickly, creates a unique psychological environment. Astronauts on the International Space Station, ISS, experience isolation, but their situation is not comparable to what the first crew on Mars will face. The ISS orbits Earth in low Earth orbit, and astronauts there can see their home planet, communicate in real time with mission control, and return to Earth within hours if necessary. On Mars, however, there will be no such comfort. The sheer distance from Earth will make home feel like a distant memory, with only delayed video messages and transmissions to remind the crew of the world they left behind. The psychological strain of isolation can manifest in many ways: loneliness, depression, anxiety, and even tension among crew members. Each individual will need to cope with the mental challenge of living so far from everything they know, without the possibility of escape. To prepare, astronomical training to help them manage stress, develop coping mechanisms, and learn how to communicate effectively in tight-knit groups. Coping with confinement and monotony. In addition to isolation, there is the challenge of confinement. Mars will not offer the expansive living spaces we enjoy on Earth. The crew will spend the majority of their time in small, pressurized habitats, working in limited spaces with the same people day after day. While the landscape of Mars itself is vast and awe-inspiring, astronauts will only occasionally venture outside for brief, carefully controlled exploration missions. Confinement has been shown to affect mood, productivity, and interpersonal relationships. Astronauts will be trained to deal with the monotony of a routine that will likely be predictable. Sleep, eat, work, repeat. Unlike Earth, where the environment constantly changes and we have the freedom to move around and experience novelty, life on Mars will be far more static. Days will blend together, and maintaining mental stimulation will be critical to avoiding burnout or boredom. To combat these challenges, mission planners are developing ways to break the monotony. One approach involves creating a structured daily schedule that balances work, exercise, social interaction, and downtime. Virtual reality (VR) might play an important role in this process, allowing astronauts to escape into simulated environments that offer mental breaks from their confined reality. Whether it's exploring Earth landscapes, playing games, or even virtually socializing with friends and family back home, VR could be a powerful tool in maintaining mental health on Mars. Interpersonal dynamics. Living in such close quarters, interpersonal relationships will be tested. The team dynamic is essential to the success of any space mission. On Mars, conflicts or breakdowns in communication could have disastrous consequences. Unlike on Earth, there will be no immediate outside intervention to resolve disagreements or tensions. The crew must learn to handle these situations on their own, relying on trust, empathy, and conflict resolution skills. Astronaut selection is therefore critical. Crews will be chosen not only for their technical expertise but for their ability to function in high-stress environments over long periods. Emotional intelligence, resilience, and the capacity to work well in a team are just as important as scientific or engineering skills. Before departing, astronauts undergo extensive psychological testing and team-building exercises to ensure they can function harmoniously under pressure. It's not just about getting along, though. It's about forming a bond strong enough to endure the highs and lows of life on another planet. Shared experiences, a sense of collective purpose, and regular communication will be key to maintaining a positive crew dynamic. Astronauts will also need to stay aware of their own emotional and mental states, recognizing when they need to take a break, ask for help, or provide support to others. The physical toll of Mars environment. Mars presents a unique set of physical challenges. The planet's gravity is only about 1/3 of Earth's, which will have profound effects on the human body. Over time, exposure to low gravity can lead to muscle atrophy and bone density loss, as the body no longer has to work as hard to support its own weight. This effect has been observed in astronauts on the ISS, where regular exercise is required to mitigate these effects in microgravity. On Mars, while gravity is stronger than on the ISS, it is still much weaker than Earth's. This means that astronauts will need to engage in daily exercise routines designed to maintain muscle mass and bone strength. Equipment like resistance machines and treadmills will be vital, helping the crew keep their bodies in shape despite the reduced gravitational load. The Martian environment also poses other physical risks. The atmosphere is not breathable, so every excursion outside the habitat will require a pressurized suit and an oxygen supply. These spacesuits will need to be flexible enough for astronauts to perform tasks while offering protection from Mars' cold temperatures and radiation. Over time, prolonged use of these suits, combined with the daily routine of living in a pressurized environment, could lead to fatigue and stress on the body. Radiation is another major concern. Without Earth's protective magnetic field, astronauts on Mars will be exposed to much higher levels of cosmic radiation. This exposure increases the risk of cancer and other health issues. Mission planners are exploring ways to mitigate this risk, including building habitats underground or using the Martian soil, regolith, as a shield. Even so, radiation will remain a long-term challenge for human health on Mars. Adaptation and resilience. Despite these challenges, the human body and mind are remarkably adaptable. Throughout history, people have thrived in some of Earth's most extreme environments, from polar regions to the depths of the ocean. On Mars, astronauts will rely on this same adaptability. Over time, their bodies will adjust to the lower gravity, and they will develop routines and coping mechanisms to deal with the psychological stress of isolation and confinement. Astronauts are chosen for their resilience, their ability to remain focused and positive even in the face of adversity. But they will not face these challenges alone. NASA and other space agencies will provide them with ongoing support, including regular psychological check-ins, communication with loved ones, and tools to manage stress and mental health. As the mission progresses, new technologies and strategies will be developed to make life on Mars more comfortable and sustainable. What's more, the sheer magnitude of the mission, the knowledge that they are part of one of the greatest human endeavors in history, will provide astronauts with a sense of purpose that can help them overcome even the most difficult moments. They are not just surviving on Mars, they are paving the way for future generations of explorers. A new type of human experience. Life on Mars will redefine what it means to be human. Astronauts will live in an environment where the familiar rules of Earth no longer apply. Time, distance, and even gravity will have different meanings. But in adapting to these new realities, astronauts will gain a deeper understanding of both Mars and themselves. Their experience will teach us more than just how to survive in space. It will reveal what we are truly capable of as a species. The challenges of isolation, confinement, and physical hardship will push human limits, but they will also expand them. In the process, the first Martians will lay the foundation for a future where humans not only explore distant worlds but learn to live on them. Next, we'll explore the possibility of terraforming Mars. Is it science fiction, or could humanity one day transform the planet into a more Earth-like environment? Chapter 7: Terraforming Mars. Science fiction or future reality? As we think about living on Mars, one idea consistently sparks the imagination: the possibility of transforming the red planet into something more like Earth. Could we, in time, create an environment on Mars where humans can walk outside without spacesuits, where plants grow freely, and where lakes and rivers flow under blue skies? This concept, known as terraforming, is a bold vision that has captivated scientists, science fiction writers, and dreamers alike. Yet, as exciting as the idea of terraforming is, it remains a monumental challenge, one that sits at the crossroads of science, engineering, and philosophy. Transforming an entire planet requires not only technological innovation but a deep understanding of the complex environmental systems that make a planet habitable. While some see terraforming as the ultimate goal of human expansion into space, Others argue that the sheer scale and uncertainty make it closer to fiction than reality. Let's explore the concept of terraforming Mars and consider the possibilities, challenges, and ethical questions that surround it. The vision of a transformed Mars. Terraforming Mars, at its core, is about creating a self-sustaining, Earth-like environment on a planet that currently cannot support human life. The most critical challenge is Mars' thin atmosphere. With atmospheric pressure less than 1% of Earth's, and composed primarily of carbon dioxide, Mars is inhospitable to humans and most known life forms. If we could thicken the atmosphere, increase its temperature, and introduce oxygen, Mars might become more suitable for human habitation. The process would begin by warming the planet. Mars is much colder than Earth, with average surface temperatures around -60 degrees Celsius. Warming the planet would allow for liquid water to exist on the surface, a key requirement for sustaining life. Scientists have proposed several ways to accomplish this, from releasing greenhouse gases to trapping more heat, to installing giant mirrors in orbit that reflect sunlight down to the planet's surface. These methods, while theoretically possible, would require significant technological advances and large-scale engineering efforts. Once the temperature rises and ice starts to melt, we could begin the next phase, creating a breathable atmosphere. This would involve increasing the oxygen levels, either through the use of photosynthetic organisms or advanced chemical processes. Oxygen is a byproduct of plants and microorganisms, and some scientists envision using specially designed plants or microbes to slowly convert carbon dioxide into oxygen. However, this process could take centuries, if not millennia, to create an atmosphere thick enough for humans to breathe without assistance. Ultimately, the goal would be to establish a balance where the planet's atmosphere and ecosystems can maintain themselves, much like Earth's. The dream is not just to survive on Mars, but to thrive, to grow forests, and perhaps even establish a new Earth-like environment where future generations can live, work, and grow. The science and the challenges. While the vision of a terraformed Mars is compelling, the science behind it reveals significant hurdles. Mars is a planet that has fundamentally different conditions from Earth, and these differences pose serious challenges to any large-scale transformation efforts. One of the biggest challenges is Mars' lack of a magnetic field. On Earth, the magnetic field protects us from harmful cosmic radiation and solar winds. Mars, however, lost its magnetic field billions of years ago, which is one of the reasons its atmosphere is so thin today. Solar winds have slowly stripped it away. Without this natural shield, any atmosphere we create on Mars could be vulnerable to the same process. This raises the question, even if we managed to thicken Mars' atmosphere, could it be sustained over time? Another challenge is the amount of energy and resources needed. Warming the planet, thickening the atmosphere, and introducing oxygen would require a massive, continuous input of energy. Some proposals suggest using nuclear fusion or solar power to generate the energy needed for these processes, but these technologies are still in their infancy. Moreover, the scale of the operation, covering an entire planet, means that it would take centuries, if not longer. Water is another critical component. While there is water ice on Mars, it's locked in polar ice caps and possibly underground. Melting this ice and creating a stable water cycle would be essential for terraforming, but it's unclear how much accessible water Mars really has, or how difficult it would be to manage once released. Water is crucial not just for life, but for regulating the climate. Without enough of it, creating Earth-like conditions would be impossible. Then there's the question of sustaining plant life. Mars soil is rich in toxic chemicals called perchlorates, which would need to be neutralized before plants could grow. In addition, the planet's low gravity could affect how plants grow and thrive. Even if we managed to modify the atmosphere, we would need to address these challenges to make Mars truly habitable for Earth's ecosystems. Is terraforming ethical? The idea of transforming an entire planet raises profound ethical questions. Mars is a world unto itself, with its own history and potentially its own forms of life, albeit microbial or hidden in its subsurface. Terraforming would irreversibly alter this planet, potentially destroying any native ecosystems that exist. One key ethical question is, do we have the right to alter another planet? Some argue that as humans venture into space, We should act as stewards, not conquerors, preserving Mars in its natural state for future generations to study and explore. Others counter that if Mars is lifeless, transforming it into a habitable environment could be the ultimate act of creating life. After all, we would be taking a dead or dormant world and bringing it to life in a way that benefits humanity and the broader ecosystem. Another consideration is the potential for unintended consequences. On Earth, we've seen how human activities can disrupt natural systems, leading to environmental degradation and climate change. If we attempt to terraform Mars, we risk creating a situation we cannot fully control. The complexity of planetary ecosystems means that small changes can lead to unpredictable outcomes, which could make Mars less hospitable than it is now, or worse, lead to catastrophic failure. The idea of Mars as a second home for humanity also raises questions about equity and access. Who would have the right to live on a terraformed Mars? Would it be limited to a select few, those with the resources to afford it? Could the drive to terraform Mars distract from efforts to address the environmental challenges we face on Earth? These are questions that we will need to grapple with as we move forward with space exploration, a far future dream. At present, terraforming remains firmly in the realm of the future, a goal that, even in the most optimistic scenarios, would take centuries to achieve. The idea is inspiring and pushes us to think about humanity's role in the universe, but it's also a reminder of how much we still have to learn about the planets around us and the complex systems that make life possible. For now, our focus is on learning how to live on Mars as it is, adapting to the planet's current conditions rather than reshaping them. But even as we work on these practical, near-term goals, the dream of terraforming Mars continues to inspire scientists, engineers, and thinkers to push the boundaries of what's possible. Terraforming Mars may one day represent the pinnacle of human ingenuity, a symbol of our ability to create, explore, and adapt. Or it may serve as a cautionary tale about the limits of our ambition and the unforeseen consequences of large-scale planetary engineering. Either way, the idea of turning Mars into a living, breathing world reminds us of the extraordinary possibilities that await humanity in the vastness of space. Next, we'll explore how Mars could serve as a stepping stone for the broader colonization of space. What lessons could we learn from establishing a foothold on Mars, and how might they shape our future beyond the Red Planet? Chapter 8: Mars and the Future of Space Colonization. The idea of Mars as humanity's next home is more than a vision for our immediate future. It represents the first step towards something even larger, the colonization of space. Mars is not just a destination, it's a testing ground for what may come next. The knowledge we gain from living and working on the Red Planet could be the foundation for human expansion beyond our solar system. But what makes Mars so essential in this grand narrative, and how can we use it as a stepping stone for deeper exploration? Mars, the gateway to the stars. Mars presents an opportunity like no other. Its proximity to Earth and its relatively familiar environment make it a logical first step for human colonization. While incredibly hostile compared to Earth, Mars is far more accessible than other worlds in our solar system. Establishing a human presence on Mars could teach us how to live on planets with harsh climates, different atmospheres, and challenging conditions. Mars allows us to practice living off Earth in a way that the Moon cannot. While the Moon is closer, its lack of atmosphere and extreme temperature fluctuations make it less of a candidate for long-term human settlement. Mars, with its atmosphere, however thin, seasons, and evidence of water, gives us a better shot at creating a self-sustaining colony. If we can thrive on Mars, we can apply that knowledge to even more extreme environments elsewhere in the solar system or beyond. The technological advancements developed for Mars, habitat construction, resource extraction, sustainable life support systems, are not just useful for this planet alone. They are prototypes for how humanity could live on the moons of Jupiter or Saturn, or perhaps on planets orbiting other stars. Mars is the proving ground for humanity's future as an interplanetary species. Lessons from Mars: sustainability and self-sufficiency. One of the biggest challenges for space colonization is the need for sustainability. On Earth, we have easy access to air, water, and food, but none of these will be freely available on Mars. Colonizing Mars will require us to learn how to live in an environment that doesn't naturally support human life. The goal is not just to survive, but to create a thriving, self-sufficient colony that can exist without constant resupply from Earth. This is where Mars becomes the ultimate test for sustainability. From producing oxygen and water to growing food in Martian soil or hydroponic systems, everything will need to be managed carefully. Over time, the colony would need to generate its own power, maintain its infrastructure, and provide for the needs of its inhabitants without relying on Earth. The lessons learned from this experience could be applied to future colonies on even more distant worlds. Living sustainably on Mars will force us to rethink how we use resources. Recycling will be essential, not just for water and air, but for materials used in construction and everyday life. This closed-loop system, where everything is reused and nothing is wasted, could have enormous implications for how we approach resource management back on Earth as well. In a sense, Mars might teach us how to be better stewards of our own planet by pushing us to invent more sustainable practices. The psychological leap, expanding human horizons. Moving to Mars will change not only how we live but also how we think about our place in the universe. For centuries, humanity has been bound to Earth, with the idea of living on another world existing only in the realm of science fiction. Colonizing Mars would represent a profound shift in human consciousness. No longer would we be limited to one planet. Mars would mark the beginning of a future where humans are truly a spacefaring species, capable of living in multiple places across the galaxy. The psychological leap that comes with colonizing Mars cannot be underestimated. Living on another planet will reshape how we view ourselves and our relationship with the universe. It will inspire new cultural, social, and philosophical perspectives. What does it mean to be human when we are no longer tied to a single world? How will life on Mars influence art, literature, and our understanding of society? These questions will become central to the human experience as we expand our reach into the cosmos. Moreover, the experience of colonizing Mars could pave the way for new forms of governance and social structures. How will we organize ourselves on a new planet? Will Martian colonies be extensions of Earth governments, or will they develop their own systems of self-rule? These challenges are more than technical. They are deeply human questions about identity, belonging, and the future of civilization. Mars as a blueprint for future colonies. If we succeed in establishing a human presence on Mars, it will provide a blueprint for future colonies in even more distant and challenging environments. The moons of Jupiter and Saturn, such as Europa and Titan, are intriguing candidates for future exploration. Europa's subsurface ocean and Titan's dense atmosphere make them prime targets for potential colonization, but they pose even greater challenges than Mars. The techniques developed on Mars, using local resources, creating livable habitats, and maintaining a self-sufficient environment, will be essential as we look to these outer moons. While living on Titan or Europa may seem like science fiction today, the same could have been said about Mars just a few decades ago. As we push the boundaries of what's possible, each new step becomes a platform for the next. Beyond our solar system, Mars could serve as a stepping stone for interstellar exploration. The idea of sending humans to planets orbiting distant stars may seem like a far future dream, but Mars could be the first step in developing the technologies and skills needed to make it a reality. Colonizing Mars is not just about expanding within our solar system. It's about setting the stage for humanity's broader journey into the cosmos. The moral and philosophical questions of colonization. As we consider colonizing Mars and beyond, there are deeper moral and philosophical questions that must be addressed. What is our responsibility to the places we colonize? Should we treat Mars and other planets as blank slates, free to be reshaped and inhabited as we see fit, or should we approach them with a sense of stewardship, preserving their natural environments? These questions will become increasingly important as we expand our reach into space. There is also the question of who gets to go. Space colonization will likely begin with a select few, chosen for their skills, health, and ability to withstand the rigors of living in extreme environments. But as colonization expands, issues of equity and access will come to the forefront. How do we ensure that the benefits of space colonization are shared by all of humanity, rather than just a privileged few? These ethical questions, though challenging, are essential to the future of space exploration. As we venture into new worlds, we must think not only about how to survive but about how to build societies that reflect our highest ideals. The path forward, Mars as the next frontier. Mars is not just a distant goal, it's the next frontier in humanity's quest to expand beyond Earth. The challenges are immense, but the potential rewards are even greater. As we move closer to sending humans to Mars, we are laying the groundwork for a future where humans can live on multiple planets, each colony a new chapter in the story of human exploration. The journey to Mars is a journey of discovery, not just about the red planet, but about ourselves. It will test our ability to adapt, innovate, and cooperate on a global scale. And as we learn how to live on Mars, we will open the door to a future where the stars are no longer out of reach, but part of the human experience. Chapter 9. International Cooperation in the Mars Mission. Reaching Mars is not something any one country or organization can achieve alone. The scale of the mission, the resources required, and the risks involved make it clear that international cooperation will be essential. The journey to Mars represents one of the most ambitious endeavors in human history, and it will demand contributions from across the globe. Collaboration between space agencies, governments, private companies, and research institutions will shape the mission's success, as well as its impact on the future of space exploration. As humanity looks to Mars, the challenges and opportunities will bring nations together in ways that extend beyond technological expertise. The mission will require shared vision, pooled resources, and coordinated efforts, uniting countries with different goals, capabilities, and cultures under a common banner. This chapter explores how international cooperation is shaping the Mars mission, what it means for the future of space exploration, and the challenges that come with such a massive collaborative effort. The global nature of space exploration. From the earliest days of space travel, international cooperation has played a crucial role in advancing human knowledge. The International Space Station, ISS, stands as the most visible symbol of what nations can achieve when they work together in space. For over 2 decades, the ISS has been a model of international collaboration, with astronauts from the United States, Russia, Japan, Canada, and the European Space Agency living and working side by side. They have conducted research, tested new technologies, and learned how to live in space for extended periods, all invaluable lessons for a future mission to Mars. Mars, however, is a far greater challenge than the ISS. The sheer distance from Earth means that it will take not just a few nations but a global effort to get there. No single country has all the resources, technology, or funding to make it happen alone. And while some nations like the United States, Russia, and China have space programs capable of sending probes and rovers to Mars, putting humans on the red planet requires far more collaboration. Different countries bring different strengths to the table. NASA has been at the forefront of robotic Mars exploration, while Russia has decades of experience in long-duration space missions. The European Space Agency, ESA, contributes sophisticated scientific instruments, while Japan's Space Agency, JAXA, offers expertise in robotics and planetary exploration. China's rapidly advancing space program has already successfully landed a rover on Mars, and India's Space Agency, ISRO, has made significant strides with its Mars orbiter mission. Together, these nations and others can pool their knowledge and capabilities to tackle the immense task of reaching and sustaining life on Mars. The role of private companies. While governments have traditionally led space exploration efforts, private companies are increasingly playing a pivotal role in the journey to Mars. Companies like SpaceX, Blue Origin, and Boeing are developing the rockets and spacecraft that could one day carry humans to the red planet. SpaceX, in particular, has captured global attention with its ambitious plans to colonize Mars. Elon Musk's vision of a multi-planetary future, driven by the development of the Starship spacecraft, has sparked a new wave of interest in space travel. Private companies bring several key advantages to the Mars mission. They often operate with more flexibility and speed than government agencies, and they have the ability to attract private investment, reducing the financial burden on taxpayers. SpaceX's reusable rocket technology, for example, has dramatically lowered the cost of launching spacecraft, making Mars missions more financially feasible. Meanwhile, companies like Blue Origin are focusing on creating sustainable lunar infrastructure that could serve as a stepping stone for deeper space exploration. The relationship between public agencies and private companies is evolving into a powerful partnership. NASA, for instance, has partnered with SpaceX to transport astronauts to the ISS, and these kinds of partnerships are expected to continue as the Mars mission develops. Governments can provide regulatory support, scientific expertise, and funding, while private companies can innovate, build, and deploy new technologies quickly and efficiently. This collaboration between public and private sectors marks a significant shift in the space industry. As we move toward Mars, it's clear that the future of space exploration will involve a blend of governmental oversight and private sector creativity. Challenges of global collaboration. While international cooperation is essential, it is not without its challenges. Space exploration has always been a field marked by national pride, geopolitical competition, and strategic interests. The Cold War space race between the United States and the Soviet Union, for example, was driven as much by political rivalry as by scientific curiosity. Even today, nations see space as an extension of their strategic influence, with countries like China and India investing heavily in their space programs to assert their technological leadership. When it comes to a mission as complex and costly as sending humans to Mars, these competitive instincts must be balanced with the need for collaboration. The question of who will lead the mission, who will provide the funding, and how the benefits of Mars exploration will be shared are all critical issues. Nations may have different priorities and timelines, which could complicate the coordination of resources and efforts. For example, while NASA aims to send humans to Mars in the 2030s, other countries may have different goals or may not yet have the technology to participate fully. Balancing these timelines and expectations will require strong international agreements and a shared commitment to the mission's success. The sharing of technological advances and scientific discoveries is another potential point of contention. The technology needed to reach Mars, such as propulsion systems, life support, and habitat construction, represents valuable intellectual property. Some countries may be reluctant to share these innovations, while others might see space exploration as a national security issue, particularly when military technologies overlap with space technologies. Despite these challenges, the history of space exploration shows that cooperation is possible, even in difficult political climates. The ISS, for instance, was developed and maintained through collaboration between countries that have not always had the easiest diplomatic relationships, such as the United States and Russia. If the Mars mission is to succeed, it will require similar agreements, built on trust, transparency, and a shared vision of exploration. The spirit of global unity. Despite the complexities of international collaboration, the mission to Mars represents a unique opportunity to unite humanity around a common goal. The Red Planet doesn't belong to any one nation. It's a frontier for all of humanity. As we set our sights on Mars, we are reminded that space exploration is, at its core, a human endeavor, one that transcends borders, ideologies, and cultures. There is something deeply powerful about the idea of people from different countries working together to push the boundaries of what's possible. The mission to Mars can serve as a reminder that we are all part of the same species, living on the same fragile planet. The challenges of space, whether it's finding new resources, understanding the universe, or protecting Earth from cosmic threats, are challenges we all share. The global cooperation required for Mars could also set the tone for future space exploration, teaching us how to work together in ways that benefit all of humanity. As we move toward an era where humans live and work on other planets, these collaborations will become even more important, not just for scientific progress but for maintaining peace and cooperation in an increasingly interconnected world. A shared journey to the Red Planet. In the end, the journey to Mars will not be about one country planting its flag on the Red Planet. It will be about all of us taking the next giant leap together. The mission will require contributions from every corner of the globe, from engineers and scientists to policymakers and visionaries. Each step will bring us closer to understanding not just Mars but our place in the universe. As we look forward to the day when humans set foot on Mars, it's clear that this mission will represent the best of what humanity can achieve when we work together. It will show that when we come together to face the unknown, we are capable of extraordinary things. And perhaps as we set our sights on the stars, we will learn to appreciate the fragile, beautiful planet we all share. Chapter 10: The Ethical Dilemmas of Mars Exploration. As humanity prepares to embark on one of its greatest adventures, sending people to Mars, we must confront not only the technical and logistical challenges but also the profound ethical questions that come with exploring and potentially colonizing another world. Mars, a planet untouched by human hands, presents both an opportunity and a responsibility. Our actions there will not only shape the future of space exploration but also reflect how we value life, environments, and our role in the universe. The mission to Mars offers the chance to expand human knowledge and create a new chapter in our history, but it also comes with moral complexities that we cannot ignore. How we approach the exploration of Mars will set a precedent for the exploration of other planets and moons in the future. This chapter explores the key ethical dilemmas that we must address as we step onto the red planet for the first time. The question of life, protecting potential Martian ecosystems. One of the most significant ethical questions surrounding Mars exploration is the possibility of life on the planet. While no definitive evidence has been found, Mars has conditions that suggest it could have once supported life, and might still, in the form of microbes hidden beneath its surface. If life does exist, even in the simplest form, we must consider our responsibility to protect it. The discovery of life on Mars would be one of the most profound scientific achievements in history, reshaping our understanding of biology, evolution, and the uniqueness of Earth. However, it also raises difficult ethical questions. Should we alter or potentially harm an ecosystem, no matter how primitive, just to satisfy our own curiosity or needs? If Martian life exists, it may be fragile and vulnerable to contamination from Earth organisms, which could disrupt its natural development or even drive it to extinction. Planetary protection protocols, developed by agencies like NASA, aim to prevent the contamination of other planets with Earth-based life. These protocols are designed to ensure that any spacecraft or human missions are sterilized to the highest standards. But as we plan to send humans to Mars, the risk of contamination increases. Unlike robotic missions, human presence introduces a much greater chance of accidentally introducing Earth microbes to the Martian environment. On the other hand, if no life is found on Mars, should we still protect its environment? Some argue that a lifeless Mars is fair game for human colonization, while others believe that even a barren planet deserves careful stewardship. Mars, in its natural state, is a geological time capsule, holding clues to the history of our solar system. Altering it could erase valuable scientific information, in future generations from Mars as it is today. Terraforming and the right to alter a planet. The idea of terraforming Mars, modifying its environment to make it more Earth-like, is a bold vision that has captivated scientists and space enthusiasts alike. But it raises deep ethical concerns. Do humans have the right to change an entire planet to suit our needs, even if it is currently uninhabited? What are the long-term consequences of such actions, both for Mars and for our own understanding of our place in the cosmos? Terraforming would require large-scale interventions, such as releasing greenhouse gases to warm the planet, melting polar ice to create liquid water, and introducing oxygen-producing organisms. These changes could potentially make Mars habitable for humans, but they would also permanently alter the planet's natural state. Supporters of terraforming argue that transforming Mars could be humanity's next great achievement, offering a solution to overpopulation or environmental challenges on Earth. They see it as a step toward becoming a multi-planetary species, ensuring our survival in the event of a catastrophe on Earth. Mars, they argue, is a barren world, and giving it life would be a positive act. However, critics point out that the ethical implications of such an undertaking are enormous. Altering a planet's climate and surface could have unpredictable consequences, and there is no guarantee that we could control the outcome. Furthermore, by reshaping Mars, we might lose the opportunity to study it in its natural form, depriving future scientists of valuable knowledge about its history and evolution. Terraforming also forces us to confront our relationship with nature. On Earth, humanity has already formed much of the planet, often with devastating environmental consequences. Should we carry these same patterns of exploitation and transformation into space, or should we take a more restrained, respectful approach? These are questions that go beyond science and technology, touching on philosophy, ethics, and the very definition of progress. Who owns Mars? The politics of space. Another fundamental ethical dilemma is the question of ownership. As humans venture beyond Earth, we must decide who has the right to claim, govern, and benefit from the resources of other planets. Mars, like the Moon, is governed by international agreements such as the Outer Space Treaty, which was signed in 1967. The treaty states that outer space, including Mars, is the province of all mankind and cannot be claimed by any single nation. However, as we move closer to actual human settlement on Mars, the legal framework surrounding space exploration becomes more complex. Who will control the colonies on Mars? Will they be governed by Earth-based nations or international organizations? How will we ensure that Mars resources are shared fairly, rather than exploited by a few wealthy nations or corporations? Conclusion: the new era of space exploration. The mission to Mars represents more than just a bold scientific endeavor. It's the next step in humanity's ongoing quest to explore, to learn, and to push beyond the boundaries of what we thought. As we stand at the edge of this new frontier, Mars invites us to imagine a future where humans live on multiple worlds, where our reach extends beyond the confines of Earth, and where space becomes a natural part of human existence. Mars is the most immediate and attainable goal, but it's also a gateway to the future. The knowledge and experience we gain from setting foot on the red planet will set the stage for even greater journeys. We are preparing not just to visit another planet, but to make a home there, to build a life on Mars that goes beyond the brief footprints left by astronauts and extends to the possibility of a permanent human presence. The significance of Mars for humanity. Exploring Mars is not just about curiosity or scientific discovery, though those are important elements. It's about survival, growth, and the expansion of human potential. Earth has been our home for millennia, but as our planet faces increasing environmental challenges, overpopulation, and limited resources, Mars offers us an opportunity to think about the future of humanity in a new way. The mission to Mars is a symbol of our capacity to adapt, innovate, thrive in even the most hostile environments. It reflects our deep desire to learn more about our place in the universe and to find out if life exists, or has ever existed, beyond our planet. The search for signs of life on Mars touches on some of the most profound questions about who we are and where we come from. Are we alone in the cosmos, or is life a fundamental part of the universe? But Mars also represents something deeper: hope. It's a chance to start fresh, to build a new world where we can apply the lessons we've learned from Earth. The challenges we face today, environmental destruction, social inequality, political divisions, remind us that Earth is fragile. Mars gives us a chance to think about how we might build a better society, one based on cooperation, sustainability, and shared responsibility. The lessons we learn from living on Mars could very well help us solve some of the problems we face here on Earth. A collective human endeavor. The journey to Mars is not one that any single person, company, or nation can take alone. It requires the efforts of scientists, engineers, astronauts, policymakers, and dreamers from around the world. It is a collective human endeavor, a project that belongs to all of us, regardless of nationality, culture, or background. Mars can be a unifying force, bringing together nations and communities in pursuit of a shared goal. The international cooperation required to make this mission a reality is an inspiring reminder of what we can achieve when we work together. This kind of collaboration extends beyond technical expertise. It touches on the very essence of what it means to be human, to explore, to challenge the unknown, and to do it with others. Looking ahead, the success of the Mars mission could set the tone for future space exploration. The partnerships we form today between governments, private companies, and international organizations will lay the groundwork for how we approach space as a shared resource in the future. Mars is a chance for us to prove that space doesn't have to be a battleground of competing interests, but a domain where we can work together for the betterment of all. A new chapter in human history. In the grand sweep of human history, the decision to send humans to Mars will be remembered as a defining moment. It will mark the point at which we became a truly spacefaring species, no longer confined to one planet but capable of reaching out to others. Mars will be a chapter in the larger story of human exploration, one that began when early humans first walked across continents, crossed oceans, and looked to the stars. We are driven by the same instinct that pushed those early explorers, a desire to understand the world, to see what lies beyond, and to find new opportunities. But now we are no longer limited to our own planet. Mars is the next step, but it won't be the last. The technological innovations and lessons we gain from Mars will open doors to deeper exploration, perhaps to the moons of Jupiter or Saturn, or even to planets beyond our solar system. The future is vast, and Mars is just the beginning. Mars, a vision of what's possible. As we stand on the brink of the Mars mission, we are reminded of how far we've come. From our first steps on the moon to the development of international space stations, to the rovers that now traverse Mars' dusty surface. Each step has brought us closer to this moment, where humans will cross the greatest frontier we have ever known. Mars is not just a destination. It's a symbol of what's possible when we dare to dream big and work hard to make those dreams a reality. It represents our capacity for innovation, resilience, and wonder. And as we prepare to take that next giant leap, we carry with us not just the tools and technologies that will make it possible, but the hopes and aspirations of all humanity. Mars will change us, not just as individuals, but as a species. It will expand our understanding of the universe and our place in it, and it will remind us that no matter how vast the challenges, we are capable of meeting them together. This is the dawn of a new era of space exploration, one that will take us farther than we have ever imagined. And it starts with Mars. The Future of Space Tourism, Exploring the Next Frontier. Written and published by Ciro Ermisai. Feel free to subscribe for more content. Now let's get into the book. Introduction. The New Frontier, Exploring Space as a Tourist Destination. For centuries, humanity has gazed up at the stars with awe and wonder, dreaming of what lies beyond our planet. What was once the stuff of science fiction, journeys to the moon, orbiting the Earth, and exploring the depths of space, is now becoming a reality. We are standing at the dawn of a new era, one where ordinary people, not just astronauts, will have the chance to experience the wonders of space firsthand. Welcome to the age of space tourism. In recent years, a revolution has quietly taken place in the aerospace industry. Private companies, fueled by bold ambitions and groundbreaking technology, are racing to open the cosmos to commercial travel. Names like SpaceX, Blue Origin, and Virgin Galactic have transformed the impossible into the achievable. These pioneers have turned their focus to a market that few could have imagined even a few decades ago, sending tourists into space. But what does space tourism really mean? It is not just a joyride for the ultra-wealthy, nor is it simply about satisfying humanity's innate curiosity. Space tourism represents a monumental shift in how we view our place in the universe. It offers new opportunities for exploration, research, and economic growth, and it poses important questions about sustainability, accessibility, and governance. This book explores the rapid rise of space tourism, looking at the key players driving the industry, the technologies making it possible, and the experience that awaits those fortunate enough to take part. We will also consider the challenges, legal, ethical, and environmental, that come with opening space to commercial travel. As we stand on the precipice of this new frontier, it's clear that space tourism will not only redefine travel but will reshape how we think about our planet, our environment, and the vast unknown that surrounds us. The future of space tourism is thrilling, but it is also complex. This book aims to unpack that future, providing a roadmap to the stars for both dreamers and pragmatists alike. Join us as we explore the next giant leap for humanity, turning space into the ultimate travel destination. Chapter 1. The Rise of Space Tourism. From Science Fiction to Reality, a Historical Overview. Not long ago, the idea of space tourism seemed like pure fantasy, a dream reserved for the pages of science fiction novels and the imaginations of filmmakers. Yet, over the last few decades, the dream of traveling beyond Earth's atmosphere has steadily evolved from fiction into reality. This chapter explores the fascinating journey of space tourism, tracing its origins from speculative fiction to the early steps that have brought us to the verge of a booming industry. The visionaries, science fiction, and early imaginings. Long before engineers began building rockets capable of leaving Earth, writers were already dreaming of interplanetary travel. In the late 19th and early 20th centuries, authors like Jules Verne and H.G. Wells thrilled readers with tales of moon voyages and extraterrestrial adventures. These stories fired the imaginations of millions, planting the seeds for a vision of space travel that would endure for generations. However, it wasn't until the space age of the mid-20th century that real progress began. The Soviet Union's launch of Sputnik in 1957 and the subsequent space race between the US and the USSR ignited global interest in space. While these efforts were focused on scientific exploration and military advantage, they laid the groundwork for the future of human space travel. The idea that someday space might be open to civilians, ordinary people, not just astronauts, began to take shape. The first space tourists, from the Cold War to the new millennium. The concept of space tourism didn't gain serious traction until the end of the Cold War. With the dissolution of the Soviet Union in the 1990s, Russia, eager to fund its cash-strapped space program, opened up the possibility of commercial space flights. In 2001, Dennis Tito, a wealthy American entrepreneur, became the first private citizen to pay for a trip to space. Tito's journey to the International Space Station, ISS, facilitated by Russia's space agency and aboard a Soyuz spacecraft, marked a monumental moment in the history of space tourism. Tito's flight was a turning point. For the first time, space travel was not limited to government astronauts or scientists. Though extremely expensive, Tito reportedly paid $20 million for his trip. It signaled that space was no longer out of reach for civilians, at least for those with the financial means. Over the next few years, a handful of other wealthy individuals followed in Tito's footsteps, purchasing their own tickets to space aboard Russian spacecraft. However, these early space tourists were the exceptions, not the norm. The technology and infrastructure necessary for routine commercial space travel were still underdeveloped. For most people, space tourism remained a distant dream. Enter the private sector, a new space race. In the early 2000s, a new generation of visionary entrepreneurs began to see space tourism as more than a novelty. It became a business opportunity. The private sector, led by companies like SpaceX, founded by Elon Musk in 2002, Blue Origin, founded by Jeff Bezos in 2000, and Virgin Galactic, founded by Richard Branson in 2004, began investing heavily in space technology with an eye toward commercializing space travel. The motivations of these entrepreneurs varied. For Musk, space tourism was a stepping stone toward his ultimate goal of colonizing Mars and ensuring humanity's survival as a multiplanetary species. For Bezos, space tourism represented a way to expand human civilization beyond Earth, eventually leading to the creation of space habitats. Branson, by contrast, had a more straightforward goal: to make space tourism an accessible and thrilling experience for adventure-seeking civilians. These companies introduced several innovations that dramatically lowered the cost of space travel and increased its feasibility for commercial purposes. Reusable rockets, pioneered by SpaceX with the Falcon 9, revolutionized the economics of spaceflight, making it far cheaper to launch payloads and passengers into space. Meanwhile, Blue Origin's New Shepard suborbital rocket and Virgin Galactic's Spaceship Two were designed specifically with tourists in mind, aiming to offer short, relatively affordable space flights for paying customers. The present moment, the industry takes off. As of today, space tourism is no longer a distant possibility, it is happening. In 2021, Blue Origin made headlines when it successfully launched its first crewed spaceflight, with Jeff Bezos himself on board. That same year, Virgin Galactic's Spaceship Two carried its first passengers, including Richard Branson, to the edge of space. SpaceX, which had already demonstrated its capabilities by sending astronauts to the ISS, has also entered the space tourism market with plans for private missions around the moon and beyond. These milestones represent the beginning of what many believe will be a booming industry. Analysts predict that by the 2030s, space tourism could become a multi-billion-dollar market, with companies offering everything from suborbital joyrides to extended stays in space hotels. As prices continue to decrease and technology improves, space travel may soon be within reach for a broader segment of the population. Challenges and opportunities. Despite the excitement, significant challenges remain. The high cost of space travel means that, for now, it is still limited to the ultra-wealthy. Furthermore, concerns about the environmental impact of rocket launches, as well as the regulatory and safety frameworks needed to ensure the industry's growth, must be addressed. However, the potential rewards are immense. Space tourism could open up new avenues for scientific research, foster international cooperation, and inspire the next generation of explorers. It could also serve as a catalyst for further technological innovation, pushing the boundaries of what is possible in aerospace engineering and space exploration. A new era begins. The rise of space tourism is one of the most exciting developments of the 21st century. What was once a dream shared by a few visionaries is now a reality, with the potential to revolutionize how we think about travel, exploration, and our place in the universe. As we look to the future, it's clear that space tourism will continue to evolve, shaping not only the aerospace industry but the very fabric of human experience. Chapter 2. Key players in the space tourism industry. Companies leading the way, SpaceX, Blue Origin, and more. The emergence of space tourism as a viable industry has been driven largely by a handful of visionary companies and the daring entrepreneurs behind them. These companies have not only revolutionized space travel by making it more affordable and accessible, but they have also injected a sense of excitement and competition into the space industry that hasn't been seen since the original space race. In this chapter, we'll explore the key players shaping the future of space tourism, their unique approaches, and the milestones they've achieved so far. SpaceX, pioneers of commercial space travel. No discussion of space tourism can begin without mentioning SpaceX, the company founded by Elon Musk in 2002. Originally created with the audacious goal of reducing space transportation costs and making human life multiplanetary, SpaceX has quickly become the leader in the commercial space industry. While its long-term focus is on colonizing Mars, SpaceX's achievements have already reshaped what is possible in space travel, and its impact on the space tourism industry is profound. One of SpaceX's most important contributions is the development of reusable rocket technology. Historically, rockets were discarded after each mission, driving up the cost of every launch. SpaceX changed this dynamic with the Falcon 9, the first orbital-class rocket capable of being reflown multiple times. This innovation drastically reduced launch costs, making space more accessible for a wider range of missions, including those involving civilian passengers. In addition to lowering costs, SpaceX has also created new opportunities for space tourism. The company's Crew Dragon spacecraft, which has successfully ferried NASA astronauts to the International Space Station (ISS), is also being used for private missions. In September 2021, SpaceX made headlines with its Inspiration 4 mission, the first all-civilian spaceflight, which orbited Earth for 3 days. This marked a significant milestone, proving that space tourism is no longer a dream limited to suborbital flights. Looking ahead, SpaceX has even more ambitious plans. It is developing Starship, a fully reusable spacecraft designed for deep space missions, including trips to the Moon, Mars, and beyond. Starship will be capable of carrying large numbers of passengers, and it could become a key vehicle for long-term space tourism, offering extended stays in orbit or journeys to other celestial bodies. Blue Origin, bringing space closer to home. Blue Origin, founded by Amazon's Jeff Bezos in 2000, is another major player in the space tourism race. While SpaceX has focused heavily on interplanetary travel and reusable rockets for a variety of missions, Blue Origin has specifically set its sights on making space tourism accessible to the general public. Bezos' vision for Blue Origin centers on the idea that millions of people will one day live and work in space, and tourism is the first step toward that reality. Blue Origin's primary vehicle for space tourism is the New Shepard, a fully reusable suborbital rocket designed to take passengers on brief trips to the edge of space. In contrast to SpaceX's orbital missions, which involve longer durations and more complex logistics, Blue Origin offers a simpler experience. A short, exhilarating journey that includes several of weightlessness and stunning views of Earth from space. In July 2021, Blue Origin successfully launched its first crewed mission with Jeff Bezos aboard, demonstrating the viability of commercial suborbital space tourism. One of the advantages of Blue Origin's approach is its relative affordability. While still expensive by most people's standards, a ticket on New Shepard is expected to cost significantly less than an orbital flight, making space tourism more accessible to wealthy individuals who aren't billionaires. Blue Origin is also committed to safety, having performed multiple uncrewed test flights to ensure the reliability of the system before carrying passengers. In addition to its suborbital flights, Blue Origin has larger ambitions. The company is developing a larger rocket, the New Glenn, which will be capable of carrying payloads and passengers into orbit. Furthermore, Bezos has expressed interest in building space habitats and creating a sustainable infrastructure for human life beyond Earth. These developments position Blue Origin as a key player not only in the future of space tourism but in the broader commercial space industry. Virgin Galactic, space tourism for the adventurous. While SpaceX and Blue Origin have garnered much of the attention in the space tourism industry, Virgin Galactic, founded by British entrepreneur Richard Branson in 2004, was one of the first companies to declare its intention to make space tourism a reality. Branson's vision was to create a company that would offer space flights to adventurous civilians, providing an unforgettable experience of weightlessness and breathtaking views of the Earth's curvature. Virgin Galactic's approach to space tourism is centered around its Spaceship Two vehicle, which is carried to high altitude by a mothership before being released to rocket into suborbital space. The spacecraft is designed to carry 6 passengers and 2 pilots, offering a brief but thrilling journey to the edge of space. Virgin Galactic's goal is to create a space tourism experience that is not only awe-inspiring but also comfortable and relatively accessible compared to other options. The company's first crewed spaceflight took place in July 2021, with Richard Branson himself aboard, symbolizing the beginning of its commercial space tourism service. Virgin Galactic has since started selling tickets for future flights, with prices ranging around $450,000 per seat. Though this is still far from affordable for the average person, it represents a significant step toward making space tourism a more common experience. Virgin Galactic has focused heavily on the customer experience, designing its spacecraft to provide maximum comfort and visibility during the short trip to space. Large windows offer panoramic views of Earth and the stars, and passengers are able to float freely in the cabin for a few minutes of weightlessness before returning to Earth. Emerging players, new horizons in space travel. While SpaceX, Blue Origin, and Virgin Galactic are the dominant names in the space tourism industry, other companies are beginning to emerge with their own visions for space travel. These companies, while not yet as well known, could play a crucial role in shaping the future of space tourism. One such company is Axiom Space, which plans to build the world's first commercial space station. Axiom's goal is to create a luxury space destination where tourists can stay for extended periods of time, experiencing life in low Earth orbit. The company has already signed agreements with SpaceX to ferry tourists to the International Space Station as early as 2024, laying the groundwork for future commercial space habitats. Another company making waves is Orbital Assembly Corporation, which envisions building space hotels that orbit the Earth. These space stations would provide tourists with a unique opportunity to stay in space for days or weeks, enjoying the views and experiencing zero gravity in a more luxurious setting than traditional spacecraft. Finally, Space Adventures, a company that helped arrange space flights for early space tourists like Dennis Tito, continues to offer bespoke space travel experiences. Though primarily targeting ultra-wealthy clients, Space Adventures has partnered with companies like SpaceX to offer missions that could one day include trips around the moon. The future of competition and collaboration. As competition heats up among these space tourism companies, the industry is likely to see rapid advancements in technology, safety, and accessibility. Each company has a unique approach. SpaceX focuses on long-duration orbital missions. Blue Origin emphasizes suborbital flights with a vision for sustainable space settlements. Virgin Galactic caters to thrill seekers looking for an unforgettable adventure. Yet, while competition is driving innovation, collaboration will also play a key role. Governments, space agencies, and private companies will need to work together to ensure that space tourism grows safely and sustainably. International cooperation on issues like space traffic management, environmental protection, and legal frameworks will be crucial as the number of space tourists increases. Chapter 3: The Technology Behind Space Travel. Rockets, spacecraft, and safety innovations. Space tourism is not just a matter of adventure. It is a high-stakes technological marvel. The engineering feats behind launching people into space safely and affordably are some of the most advanced in human history. While the excitement of space tourism grabs the headlines, the real driving force behind this industry is the technology. From reusable rockets to life support systems and safety measures, this chapter explores the cutting-edge advancements making space tourism possible. Reusable rockets, the game changer. The concept of reusable rockets has fundamentally altered the economics and feasibility of space tourism. In the past, space missions were prohibitively expensive, largely because rockets were single-use. Each mission required a brand-new multi-million-dollar rocket that would be discarded after just one flight. This method made space travel a one-time use affair, contributing to astronomically high costs. However, companies like SpaceX and Blue Origin have completely changed that narrative with the advent of reusable rockets. SpaceX's Falcon 9 is perhaps the most significant development in this area. First introduced in 2010, the Falcon 9 was designed with a reusable first stage that could return to Earth, land vertically, and be refurbished for future launches. This innovation drastically reduced the cost of space travel, cutting the price of launches by millions of dollars. By reusing the rocket's most expensive component, SpaceX made routine spaceflight more economically viable, which in turn opened the door for commercial applications like space tourism. Similarly, Blue Origin's New Shepard rocket is fully reusable and specifically designed for space tourism. This suborbital rocket, which carries passengers briefly into space before returning to Earth, has been used multiple times for uncrewed and crewed test flights. Each successful reuse brings down the overall cost of space tourism, making it increasingly accessible to those who can afford the experience. Reusable rockets have revolutionized space travel by drastically lowering the barrier to entry. While ticket prices for space tourism are still high, as the technology matures, the cost will continue to fall. This trend is critical for the long-term viability of the space tourism industry. Spacecraft designed for tourists. Beyond the rockets that propel people into space, the spacecraft that tourists will ride in are equally important. These vehicles are designed not only to withstand the rigors of space travel, but also to provide an unforgettable experience for passengers. Virgin Galactic's Spaceship Two is a prime example. Unlike traditional rockets, Spaceship Two is a spaceplane that is carried aloft by a mothership, White Knight 2, before being released to rocket into suborbital space. Inside the spaceplane, tourists are treated to large windows, giving them a panoramic view of the Earth's curvature and the blackness of space. The cabin is designed to maximize comfort during the brief but exhilarating experience of weightlessness. SpaceX's Crew Dragon spacecraft offers a different experience. Originally designed to carry astronauts to the International Space Station, ISS, Crew Dragon has been adapted for civilian space travel. It can carry up to 7 passengers into orbit, and its sleek, modern interior is built with safety and comfort in mind. Equipped with state-of-the-art touchscreen controls and a life support system that can keep passengers alive for extended periods, Crew Dragon is capable of long-duration missions. In the future, SpaceX plans to use Crew Dragon for more ambitious space tourism missions, including private trips around the moon. Blue Origin's New Shepard capsule, though designed for shorter, suborbital flights, also prioritizes the passenger experience. With large windows, among the biggest ever flown in space, the New Shepard capsule provides stunning views during the few minutes of weightlessness its passengers experience. Like Virgin Galactic spaceplane, Blue Origin's capsule is designed for a brief but thrilling encounter with space, and the company is focused on making the experience as safe and enjoyable as possible. The role of artificial intelligence in automation. Modern spacecraft are equipped with sophisticated systems that rely heavily on artificial intelligence, AI, and automation. These systems are essential for managing the complex processes involved in space travel, from launch to re-entry. SpaceX's Crew Dragon is largely automated, meaning that once the spacecraft is in orbit, it can operate without much input from its passengers. This makes space tourism more accessible, as travelers do not need to be trained astronauts to pilot the spacecraft. The spacecraft's AI systems handle tasks such as docking with the ISS, maintaining orbit, and managing life support functions. Passengers can focus on enjoying the experience, knowing that the spacecraft is equipped with redundant safety systems that will take over in case of an emergency. Automation also plays a significant role in reusable rockets. The ability of a rocket like SpaceX's Falcon 9 to land vertically on a floating platform in the ocean is largely due to advanced AI and real-time adjustments made by the rocket's onboard systems. This level of precision would be impossible without AI, and it is key to the success of reusable technology. As the space tourism industry grows, AI and automation will continue to enhance safety and improve the overall experience for passengers. These systems will also be crucial for longer missions, such as those to the Moon or Mars, where human oversight may be limited, and spacecraft must be able to manage complex tasks independently. Life support systems, keeping tourists safe in space. One of the most critical components of space tourism is the life support system that keeps passengers safe and healthy during their time in space. While the experience of space travel is thrilling, the environment is extremely hostile to human life. Without proper life support systems, even a short trip into space would be deadly. Spacecraft like SpaceX's Crew Dragon and Blue Origin's New Shepard are equipped with advanced life support systems that regulate oxygen levels, remove carbon dioxide, and maintain cabin pressure. These systems are designed to ensure that passengers can breathe normally and remain comfortable during their time in space. Temperature regulation is another vital function of the life support system. Space is an extreme environment, where temperatures can swing wildly between scorching heat and freezing cold. The life support systems onboard tourist spacecraft are designed to keep the cabin at a stable, comfortable temperature, protecting passengers from these extremes. In addition to regulating the cabin environment, life support systems also include emergency measures. For instance, SpaceX's Crew Dragon is equipped with an escape system that can quickly separate the spacecraft from the rocket in case of an emergency during launch. This system is designed to protect passengers in the event of a catastrophic failure, ensuring that they can return to Earth safely. Safety innovations, ensuring a safe journey. Space tourism, by its very nature, is risky. The extreme forces involved in launching people into space, the vacuum of space itself, and the challenges of re-entry all pose serious safety concerns. However, thanks to years of advancements in spaceflight technology, the risks are being mitigated. One of the most significant safety innovations is the development of abort systems that can safely return passengers to Earth in the event of a malfunction. Both SpaceX's Crew Dragon and Blue Origin's New Shepard have such systems in place. During a launch, if something goes wrong, the spacecraft can quickly separate from the rocket and deploy parachutes to bring passengers back to the ground safely. Additionally, extensive testing is a key factor in ensuring the safety of space tourists. Companies like SpaceX, Blue Origin, and Virgin Galactic conduct rigorous testing of their spacecraft and rockets before they are deemed ready for crewed missions. These tests include uncrewed flights, emergency abort scenarios, and real-world simulations designed to identify and address potential issues before humans are on board. Training for passengers is also an important aspect of safety in space tourism. While tourists are not required to have the extensive training of professional astronauts, they do undergo pre-flight preparation. This includes familiarization with the spacecraft, safety protocols, and what to expect during launch, time in space, and re-entry. By ensuring that passengers are well prepared, companies reduce the likelihood of complications during the flight. Looking ahead, Future technological innovations. The future of space tourism will be shaped by continued technological innovation. As companies push the boundaries of what is possible, we can expect to see the development of new spacecraft designed for longer duration missions, more luxurious accommodations, and even space habitats where tourists can spend days or weeks orbiting the Earth. One exciting area of development is the possibility of hypersonic travel, which would allow passengers to travel around the world in just a few hours by flying through the edge of space. This technology could revolutionize not just space tourism, but global travel, offering a new way to experience both the planet and the cosmos. As the technology behind space travel advances, it will also become safer, more efficient, and, eventually, more affordable. This progress will make space tourism more accessible to a broader segment of the population, transforming the industry from a niche market into a mainstream mode of travel. Chapter 4. The cost of space tourism. Who can afford it? The economics of space travel. While the idea of space tourism has captured the imaginations of millions around the world, the reality of its cost has, so far, made it a luxury only accessible to the ultra-wealthy. The economics of space travel, driven by the complexity and danger of launching humans into space, have kept ticket prices astronomically high. But with rapid advancements in technology and increasing competition, the industry is inching toward a future where space travel might be accessible to a wider segment of society. In this chapter, we will explore the current costs of space tourism, the financial challenges involved, and when the average person might be able to afford a trip to the stars. The current cost of space tourism. As of now, space tourism remains prohibitively expensive for all but the wealthiest individuals. The prices vary depending on the company and the nature of the trip, whether it's a suborbital flight that briefly reaches the edge of space or a longer orbital mission. Here's a breakdown of the costs associated with the leading space tourism companies. Virgin Galactic. For a suborbital flight aboard Virgin Galactic Spaceship Two, the cost of a ticket is approximately $450,000. This price includes a brief journey to the edge of space, several minutes of weightlessness, and stunning views of the Earth's curvature before returning to the planet's surface. While significantly cheaper than orbital flights, this price tag still places space tourism out of reach for the vast majority of people. Blue Origin. A trip aboard Blue Origin's New Shepard rocket, which also offers a suborbital flight and a few minutes of weightlessness, costs around $250,000 to $300,000. While slightly less expensive than Virgin Galactic, Blue Origin's flights are similarly targeted at wealthy adventurers who are willing to pay for a once-in-a-lifetime experience. SpaceX. For those seeking a more ambitious journey, SpaceX offers the Crew Dragon experience, where passengers can orbit the Earth for several days. The cost for such a mission, as seen in the Inspiration 4 flight in 2021, is estimated to be around $55 million per passenger. SpaceX also plans private missions around the Moon and eventually Mars, which will come with even higher price tags. These trips are typically financed by ultra-rich individuals or sponsored by companies as part of larger marketing or philanthropic efforts. While these prices are daunting, it's important to note that they reflect the enormous technical and operational challenges involved in sending people to space. Rockets, spacecraft, and life support systems are extraordinarily complex and expensive to build, maintain, and operate. In addition, the rigorous safety testing and training required to ensure the passengers' safety further drive up the costs. Why space tourism is so expensive? There are several factors that contribute to the high cost of space tourism. 1. Rocket and spacecraft development. Building a spacecraft capable of safely carrying humans into space requires massive upfront investments. Companies like SpaceX, Blue Origin, and Virgin Galactic have spent billions of dollars developing the necessary technology. This includes everything from the rockets that propel passengers into space to the life support systems that keep them alive in the vacuum of space. 2. Launch costs. Even with advancements like reusable rockets, each launch still costs millions of dollars. Fuel, maintenance, and operational expenses all add up. For orbital missions, these costs are even higher due to the greater distance and complexity involved. 3. Safety and regulations. Ensuring that a space tourism flight is safe involves extensive testing, certifications, and regulatory approvals. Companies must comply with a range of safety protocols set by agencies like NASA and the Federal Aviation Administration, FAA. This process is both time-consuming and expensive. 4. Insurance. Space tourism companies must also contend with the high cost of insurance. Given the inherent risks involved in space travel, insurance premiums are significant, and these costs are passed on to the customers. 5. Limited supply and high demand. At the moment, space tourism is a niche market with limited capacity. Only a handful of flights are offered each year, which keeps the prices high. As demand increases and more flights become available, there is potential for prices to decrease. But for now, the exclusivity of the experience keeps ticket prices in the stratosphere. When will space travel become affordable? While space tourism is currently limited to the wealthy elite, there is optimism that prices will eventually come down, making space travel more accessible to a broader range of people. Here are some of the factors that could help reduce costs in the future. 1. Economies of scale. As more space tourism flights are conducted, the cost per flight could decrease due to economies of scale. This is similar to how commercial airline prices decreased over time as air travel became more common. As companies refine their technologies and streamline operations, they will be able to lower prices and offer more frequent flights. 2. Technological advancements. Continued innovation in rocket and spacecraft technology will likely drive costs down. Reusable rockets have already drastically reduced costs, and further advancements could make space travel even more affordable. Companies like SpaceX and Blue Origin are continuously working to improve the efficiency and reliability of their rockets, which could eventually lead to lower prices for consumers. 3. Increased competition. As more companies enter the space tourism market, increased competition could lead to lower prices. While SpaceX, Blue Origin, and Virgin Galactic currently dominate the industry, other companies such as Axiom Space and Space Adventures are working on their own space tourism ventures. This competition could drive innovation and force companies to lower their prices to attract more customers. 4. Government support and partnerships. Governments around the world are increasingly recognizing the economic potential of the space tourism industry. Some governments may choose to subsidize or invest in space tourism as a way to promote technological innovation and economic growth. Partnerships between private companies and government agencies could help reduce the financial barriers to space travel. 5. Spaceports and infrastructure. As more spaceports and infrastructure are built around the world, the logistical challenges and costs associated with launching spacecraft will decrease. Right now, space tourism flights are limited to a few specialized launch sites, but in the future there could be a network of spaceports, similar to airports, that facilitate regular space flights. Despite these potential cost-reducing factors, it's likely that space tourism will remain a luxury for the foreseeable future. However, as prices fall, the pool of potential customers will expand. Eventually, space tourism could become comparable to the cost of an expensive international vacation, a possibility that would open the market to millions more people. Financing space travel, sponsorships and lotteries. For those who aren't billionaires but still dream of going to space, some creative solutions have already emerged. For example, the Inspiration 4 mission, which sent 4 civilians into orbit aboard SpaceX's Crew Dragon, was largely funded by a billionaire who donated seats on the spacecraft to raise awareness and funds for charity. Such sponsorships and philanthropic endeavors could provide opportunities for regular people to experience space travel, even if they can't afford the price tag. Additionally, some companies have floated the idea of spaceflight lotteries, where individuals could buy tickets for a chance to win a free trip to space. This would democratize access to space tourism, allowing a broader range of people to participate without having to pay full price. In the future, space tourism companies may also offer payment plans or financing options for customers, much like how luxury items or expensive vacations are financed today. This could make space tourism more accessible to middle-class consumers who are willing to save or take out loans to fund their journey. Long-term economic impact of space tourism. As the space tourism industry grows, its economic impact will extend far beyond just the companies involved in launching rockets. The development of spaceports, the creation of new jobs in engineering and aerospace, and the potential for space tourism to stimulate technological innovation will all contribute to a growing space economy. Tourism in space could also lead to the creation of entirely new industries. For example, there are already plans for space hotels, space-based research facilities, and even lunar and Mars colonies that could serve as tourist destinations. The economic ripple effect of these developments could be enormous, creating opportunities for businesses in a variety of sectors, from hospitality to construction. Moreover, as space tourism becomes more common, it could inspire new generations of scientists, engineers, and entrepreneurs, driving further innovation and investment in the space sector. In this sense, space tourism is not just a luxury for the wealthy but a catalyst for broader economic growth and technological advancement. Chapter 5: Space Tourism and the Environment. The impact of space travel on Earth's ecosystem. As space tourism takes off, it brings with it more than the excitement of venturing into the cosmos. While the idea of commercial space travel captures imaginations, it also raises important questions about its environmental impact. Rockets, spacecraft, and the entire infrastructure supporting space tourism have the potential to affect Earth's ecosystem in significant ways. In this chapter, we'll explore the environmental costs of space travel and examine the efforts being made to ensure that this burgeoning industry develops sustainably. The environmental cost of rocket launches. At the heart of space tourism is the rocket, an engineering marvel, but also a source of considerable environmental concern. Each rocket launch requires a massive amount of energy, primarily derived from burning fuels that release greenhouse gases and other pollutants into the atmosphere. The immediate environmental impact of these launches, particularly their carbon footprint, is a subject of growing debate. The primary fuels used in space tourism rockets today are liquid oxygen combined with kerosene or liquid hydrogen. While liquid hydrogen used by companies like SpaceX burns cleanly and produces water vapor as a byproduct, other fuels like kerosene release carbon dioxide and black carbon soot into the upper atmosphere. Black carbon in the stratosphere can contribute to climate change by trapping heat, and its long-term effects are still being studied. Furthermore, each rocket launch produces an intense thermal impact as it punches through the atmosphere. While the number of launches remains relatively low compared to commercial aviation, as the space tourism industry grows, so too will the cumulative environmental toll. Even reusable rockets, hailed for their ability to lower costs and reduce waste, still require significant fuel for each launch and re-entry. The ozone layer and atmospheric effects. Another concern is the potential damage rocket launches can inflict on the ozone layer. The ozone layer, which protects life on Earth by absorbing harmful ultraviolet radiation from the sun, is particularly vulnerable to pollutants like chlorine and alumina particles emitted by certain rocket fuels. Although the damage caused by a single launch is minimal, an increase in the frequency of launches could lead to more significant depletion of the ozone layer, particularly if no measures are taken to mitigate these effects. Studies on rocket emissions have shown that particles released in the upper atmosphere can have a longer-lasting impact than those released closer to Earth's surface. This means that the environmental footprint of space tourism may not be immediately noticeable, but its long-term effects on the atmosphere could be profound if left unchecked. Space debris, an orbiting problem. While the immediate environmental impact of rocket launches is significant, space tourism also contributes to a growing problem beyond Earth's atmosphere: space debris. Space debris consists of defunct satellites, spent rocket stages, and other fragments left behind from human activity in space. As more spacecraft are launched, especially for tourist missions, the risk of adding to this space junk increases. Space debris poses a significant threat not only to future space tourism missions but also to operational satellites and space stations. Collisions between debris and active spacecraft can have catastrophic consequences, creating even more debris in the process. Managing and mitigating space debris has become a priority for space agencies around the world, but the increasing commercialization of space tourism adds complexity to this challenge. Efforts are being made to address this issue, including designing spacecraft that can deorbit themselves after use and developing systems to remove debris from orbit. However, as space tourism grows, there will need to be strict regulations and innovative solutions to prevent the proliferation of space debris from spiraling out of control. Steps toward sustainable space tourism. As the environmental challenges of space tourism become clearer, companies and governments are beginning to take steps to ensure that this new industry develops sustainably. Several key areas of focus include reducing rocket emissions, improving fuel efficiency, and minimizing space debris. SpaceX has led the way in developing reusable rockets, which represent a significant step forward in reducing waste. Each reuse of a rocket stage lowers the environmental cost per flight, as fewer resources are needed to build new rockets for each launch. This reduces the overall carbon footprint of space tourism, though the issue of fuel emissions remains. Moreover, Blue Origin has taken steps to emphasize sustainability in its operations. The company's New Shepard rocket, which is used for suborbital tourism flights, is powered by a liquid hydrogen and oxygen fuel mix, which produces water vapor as its primary emission. This makes it one of the cleaner rocket systems in use today, though the production of liquid hydrogen still requires significant energy. There is also growing interest in the development of alternative fuels that produce fewer emissions. Some companies are researching biofuels and synthetic fuels that could be used to power rockets in the future. While these technologies are still in their early stages, they hold promise for reducing the environmental impact of space tourism in the long term. The role of regulation and international cooperation. Ensuring the sustainable development of space tourism will also require strong regulatory frameworks and international cooperation. Currently, there is no global regulatory body specifically overseeing space tourism, though agencies like NASA, the European Space Agency, ESA, and the Federal Aviation Administration, FAA, have some jurisdiction over space launches and safety. However, environmental regulation of space activities is still a developing area. As space tourism grows, governments will need to establish clear guidelines for minimizing the environmental impact of rocket launches and managing space debris. This could include setting limits on emissions, requiring companies to offset their carbon footprints, or mandating the use of technologies that reduce the environmental impact of space travel. International cooperation will be essential to address the global nature of space tourism. Just as climate change and environmental protection require collaboration across borders, so too does the management of space tourism's environmental impact. The United Nations Outer Space Treaty, which governs activities in space, provides a starting point for cooperation, but more specific environmental regulations will likely be needed as the industry grows. Space tourism as an opportunity for environmental awareness. Ironically, space tourism itself may become a powerful tool for raising environmental awareness. Astronauts and space tourists alike often describe the overview effect, a profound sense of connection and responsibility toward Earth that comes from seeing the planet from space. From this vantage point, the fragility of Earth's atmosphere and the interconnectedness of life on the planet become overwhelmingly clear. As more people experience space travel, this perspective could inspire greater environmental stewardship. Companies involved in space tourism are already recognizing this potential and emphasizing the importance of protecting Earth's environment as part of the space tourism narrative. Virgin Galactic, for example, highlights the potential for space tourism to inspire environmental consciousness by giving passengers a new perspective on Earth. Likewise, SpaceX's long-term goal of colonizing Mars is framed not only as a way to expand humanity's reach but also as a reminder of the importance of protecting Earth, the only planet we currently know can support life. Balancing exploration and environmental responsibility. The future of space tourism will require a delicate balance between human exploration and environmental responsibility. As exciting as the prospect of venturing into space is, it cannot come at the expense of the very planet that makes life possible. The technologies and policies developed today will set the foundation for a space tourism industry that can thrive without harming the environment. As space tourism expands, the challenge will be to continue pushing the boundaries of human exploration while ensuring that our impact on Earth remains sustainable. The hope is that with careful planning, innovation, and international cooperation, space tourism can open new frontiers without jeopardizing the health of our planet. Chapter 6: Legal and Ethical Considerations. Space laws, liability, and ethical dilemmas. The rise of space tourism brings with it not just technological and environmental challenges, but a host of legal and ethical questions that humanity has never faced before. As ordinary people prepare to venture beyond Earth's atmosphere, laws and regulations governing space travel need to evolve rapidly. Beyond the legal aspects, the ethical dilemmas of who gets to go to space and at what cost also become pressing. This chapter explores the legal frameworks, liability concerns, and ethical debates shaping the future of space tourism. Space law, a new frontier. Space, unlike any other destination, is governed by international law. The foundation of modern space law is the Outer Space Treaty of 1967, signed by more than 100 countries. This treaty established several key principles, including that space is the province of all mankind, meaning it cannot be claimed by any one nation or used for military purposes. It also emphasized that countries are responsible for all space activities conducted by their private citizens or companies. However, while the treaty laid the groundwork for peaceful exploration, it was written long before the concept of commercial space tourism existed. As private companies like SpaceX, Blue Origin, and Virgin Galactic lead the charge in making space travel accessible to civilians, legal frameworks need updating to address this new reality. One critical issue is whether these companies have the same obligations as national governments under the Outer Space Treaty, particularly when it comes to responsibility for potential accidents or damages in space. Many legal experts argue that while space law covers broad principles, there are significant gaps when it comes to regulating the specifics of space tourism, such as liability in case of accidents, the protection of space tourists, and the environmental impact of private space activities. Currently, governments regulate these companies, but there is no global body specifically overseeing commercial space activities. Liability and responsibility. Space tourism introduces a unique set of liability concerns. What happens if something goes wrong during a space flight? Who is held responsible for accidents, injuries, or damage caused by private space missions? In most countries, space tourism companies must obtain a license to launch spacecraft, and part of this process involves adhering to national safety regulations. In the United States, for example, the Federal Aviation Administration, FAA, oversees commercial spaceflight and mandates that companies inform passengers about the risks involved. However, these regulations still place much of the responsibility on passengers, who are required to sign waivers acknowledging the inherent dangers of space travel. In the event of an accident, the liability of the company may be limited by these waivers. At the international level, the Liability Convention of 1972 holds countries responsible for damage caused by space activities, but this primarily applies to government space agencies, not private companies. As the number of private space missions increases, questions arise about how liability should be divided between governments and companies. If a space tourist were to be injured or killed during a flight, or if a spacecraft were to crash into a foreign satellite, who would pay for the damages? These legal gray areas need to be clarified as space tourism becomes more common. Additionally, as space tourism expands to orbital flights and potentially lunar missions, liability issues will become even more complex. Space tourists will be exposed to unique risks, from exposure to radiation to the dangers of re-entry into Earth's atmosphere. While current regulations may cover suborbital flights, more detailed legal frameworks will be necessary for longer missions beyond Earth's orbit. Ethical dilemmas. Space for the few or the many. Beyond the legal aspects, space tourism raises significant ethical questions. One of the most glaring is the issue of accessibility. Currently, space travel is an exclusive experience reserved for the ultra-wealthy, with ticket prices ranging from hundreds of thousands to tens of millions of dollars. This raises the ethical question of whether space, which has been deemed the province of all mankind, should be accessible only to those who can afford it. Critics argue that space tourism is a distraction from more pressing global issues, such as poverty, inequality, and climate change. At a time when many people on Earth lack access to basic necessities, should we be spending vast amounts of resources to send a privileged few on joyrides to space? Moreover, space tourism's environmental impact adds another layer of complexity to this ethical debate. How do we justify the environmental costs of sending people to space when those resources could be used to address climate change on Earth? On the other hand, proponents of space tourism argue that it can inspire innovation and foster a deeper appreciation for our planet. The overview effect. The profound shift in perspective experienced by astronauts when they see Earth from space could help cultivate a sense of environmental stewardship among space tourists. Space tourism may also act as a catalyst for technological advancements that could have broader benefits. Much like the early space programs spurred innovations in telecommunications, medicine, and computing. The ethics of human expansion beyond Earth. As space tourism expands, so too does the possibility of human settlement beyond Earth. Visionaries like Elon Musk have long touted the idea of colonizing Mars, not just as an adventure for the few, but as a way to ensure humanity's survival in the face of existential threats like climate change or nuclear war. But this vision raises ethical concerns about the exploitation of other planets and the environmental impact of expanding human civilization into space. Should we be prioritizing the colonization of Mars, for example, when we have yet to solve many of the challenges facing Earth? Furthermore, who gets to decide how we use space resources such as lunar water or asteroid minerals? While the Outer Space Treaty states that space is the common heritage of mankind, the reality is that powerful nations and corporations are poised to dominate space exploration and resource extraction. The ethical implications of space tourism and eventual space colonization also touch on the potential for inequality in access. If only the wealthy can afford to escape to new worlds, does this create a future where the elite leave a struggling Earth behind, while the majority of humanity remains to face its challenges? These are questions that will need to be addressed as we contemplate the role of private companies in shaping the future of space exploration. Informed consent and space tourist rights. Another ethical issue concerns the safety and rights of space tourists themselves. Unlike professional astronauts, who undergo extensive training and accept the risks associated with space travel as part of their job, space tourists are often ordinary people with little or no experience in the dangers of spaceflight. While current regulations require space tourists to sign waivers acknowledging the risks, is this enough? Should space tourists receive more comprehensive training, and should companies be held to higher standards of safety? There is also the question of what rights space tourists have once they are in space. For example, if a medical emergency occurs aboard a spacecraft, what protocols are in place to ensure the tourist's safety and well-being? These are important ethical considerations that will need to be addressed as space tourism becomes more widespread. International collaboration and shared responsibility. The ethical and legal questions surrounding space tourism are not confined to national borders. Space, by its very nature, is a shared domain, and the actions of one country or company can have global consequences. As such, international collaboration will be essential in developing a fair and comprehensive framework for space tourism. International organizations such as the United Nations Office for Outer Space Affairs, UNUSA, play a key role in facilitating dialogue between countries on space issues. However, with the rapid growth of private space companies, there is a need for more robust international agreements that address the unique challenges posed by space tourism. These agreements will need to balance the interests of different countries while ensuring that space remains a shared resource for all of humanity. Navigating the legal and ethical challenges ahead. Space tourism, as thrilling and groundbreaking as it is, forces us to confront new legal and ethical challenges. From questions about liability and regulation to the broader ethical concerns of accessibility and environmental responsibility, the future of space tourism will require careful consideration and collaboration. As more people journey beyond Earth, it is crucial that we develop legal frameworks and ethical guidelines that ensure space travel benefits humanity as a whole, not just the privileged few. Chapter 7. The Experience of Space Tourists. What to expect. From zero gravity to orbital views. The allure of space tourism goes beyond the technological marvel of launching a spacecraft or the prestige of being among the few to leave Earth. It's the experience itself, the feeling of weightlessness, the breathtaking views of our planet from above, and the profound sense of perspective that comes with venturing beyond the atmosphere. This chapter delves into what space tourists can expect during their journey, from pre-flight preparations to the moment they return to Earth. The build-up, preparing for the journey. Before any space tourist leaves Earth, there's a process of physical and mental preparation that begins weeks or even months before the actual flight. While space tourists aren't subjected to the rigorous training of professional astronauts, companies like Virgin Galactic, Blue Origin, and SpaceX provide their passengers with basic training to ensure they're ready for the experience. Pre-flight training typically involves a combination of medical evaluations and familiarization with the spacecraft. Tourists undergo health checks to ensure they're fit for the journey, as space travel, even on short flights, can be physically demanding. The body's response to microgravity and the forces of launch and re-entry can put significant strain on the cardiovascular and musculoskeletal systems, so medical clearance is essential. In addition to health assessments, space tourists are given briefings on the spacecraft's systems and safety protocols. This preparation allows them to understand what to expect during launch, the time spent in space, and re-entry. While the spacecraft are largely automated, passengers are taught how to handle potential emergencies, such as cabin depressurization or communication issues. But perhaps the most exciting part of pre-flight training is the opportunity to experience simulated zero gravity. Many space tourists take part in parabolic flights, where an airplane flies in steep arcs to create brief periods of weightlessness. This gives them a taste of what it will feel like to float in space,